Okay, so today I'm going to go ahead and begin with hypothesis testing. In order to understand what hypothesis testing is all about, let me give you a brief pattern of what all we are going to study as part of hypothesis testing. See, we want to go ahead and understand what is null and alternative hypothesis. That's the first thing we want to do. Then we want to go one step ahead and we want to talk about what is type 1 and type 2 error. This is the most important topic when it comes to IIT exam, GATE exam, ISI exam. Even DSC used to ask these questions. Then IGIDR exam. So type 1, type 2 error is super important. So we will see a lot of questions on type 1, type 2 error. Then we want to do different kind of hypothesis testing. So when we talk about different kind of hypothesis testing, what are those? We will do large population single sample test or single mean test, it's called. Then we will do small population single mean test. Then we will do two sample test. This is single means single sample. So this is one sample test. This is also one sample test. Then we will do two sample tests. Then we will do something called as proportion test. Finally, it will be followed by chi-square and F-test. So this is the kind of tests that I want to cover. Every time we do a test, corresponding to that test, we should also be able to write what is called as confidence interval. So when we do tests, they're called as point intervals. But when we find an interval, it is called as confidence interval. So I will talk about these two things in a while. So I will also talk about confidence interval for each of these tests, how we can find the confidence intervals in each of these cases. That is what we will be doing. And at last, I will dedicate some time to finding p-value. That is what my aim is. This is the second majority of statistics. So if we talk about stats, it can be divided in three parts. The first majority is probability part. The second majority is, I will talk about all the tests, beta. This is proportion, this is chi-square, this is F. Huh? So the first, so what was saying? Yeah, there are three main things in which probability, in which stats can be divided. The first is going to be probability, which we covered completely. The second aspect is where you talk about hypothesis testing. These are the main topics under this. And the third part is some part of econometrics, which I will do post this. So what my aim for today's session is to help you understand what is null and alternative hypothesis, to help you understand various questions on type 1 and type 2 error, very, very important. And to do this large population single mean test and teach you a corresponding confidence interval of that. So we will do this in today's session. Let us begin the class by understanding what is a null and alternative hypothesis. Now try to understand. See, whenever we talk about any statistician, the aim of a statistician is to go ahead and understand any kind of conclusion that he wants to come to. So for example, if I want to check that the pollution in air has increased in Delhi, so I can say that, okay, on an average, in the month of November, the AQI in Delhi used to be this much. Then I will pick up a sample of 10 days data and I will find out what is the current AQI. And then I will run a hypothesis testing, asking whether there is a difference between my observed sample values and what the actual value in November used to be. So I will check whether there is a difference between the two or not. That is what hypothesis testing is doing. So you have a population. In that population you have something in mind कि अच्छा इस population में average ये रहता है. So I tell you that, you know, in my society, everyone is rich. They have very high, high income. So you tell me their average income. That on an average, people earn 10,000 per month. Then what do? You go ahead and you pick up some sample. इसी का एक sample लिया. For that sample, you will be knowing what their average income is. You will be knowing what their standard deviation is. Your aim is to compare, to find out the information from this sample, and on the basis of the information from the sample, you want to find out whether it is true to the population or not. For all such cases, wherever you test the sample and you want to conclude something about the population, that is what is hypothesis testing. So I have a data of the sample. I am trying to estimate the value of the population based on the sample. That is what is hypothesis testing. Now, what is null and alternative hypothesis? So whatever you want to test, just say you want to prove that pollution has increased. So you want to prove that AQI has exceeded a certain number. It has exceeded 450. It's in Delhi. Whatever you want to prove, that will be called your alternative hypothesis. And the opposite of that will be your null hypothesis. So whatever the researcher wants to prove, that is always a part of the alternative hypothesis, right? So if I just go ahead and I read the definition, what is a null hypothesis? A null hypothesis is tested for possible rejection. So mere dimag mein I have to, my aim is to reject the null and my aim is to go towards alternative. So what I want to support as a researcher, that is what is called an alternative hypothesis. And what I want to reject, under the assumption currently it is true. Abhi sab meko bol rahe hain ki nahi, pollution to kam hi hai. So I'm assuming that pollution is less, but I want to prove other way around. So what I want to reject, that should be written in the null hypothesis. Now, when we talk about alternative hypothesis, it is of two types. Either it can be two-tail or it can be one-tail. A two-tail alternative hypothesis means that you have not equal to sign in the alternative hypothesis. But a one-tail alternative hypothesis is where you specify the sign. So you say, Acha, okay, I think that, suppose you tell me that do men earn more than women? So I am using the statement more than, less than. So when you use these signs, more than or less than, that is called as your one-tail hypothesis. So a two-tail hypothesis is one where you have this sign not equal to, and a one-tail hypothesis is one where you have these signs greater than or less than. Let me give you some examples and that will make things clear. So let's read this down. Consider a random sample, beta ye sample ka size diya hua hai, of 100 carpenters producing a sample mean of 15 and standard deviation 2. Abhi ke liye kuch nahi karna. I am just teaching you how to write null and alternative. You wish to show average hourly wage of carpenter in the state of US is different from 14. क्या दिखाना है? कि wage 14 से अलग है. This is what you wish to show. You wish to show that the wage is different from 14. So what you wish to show should be alternative. So I wish to show that the wage is not equal to 14. It is different from 14. So that becomes my alternative. So what will be my null? Equal to 14. So my null will become that the average wage is equal to 14. So this is how we will write null and alternative. Null is the opposite of alternative. Alternative is what you wish to show. If you wish to show that wage is not equal to 14, that will become your alternative and the other will become your null. Let's read one more question. A teacher claims that median time to do a particular problem of stats is at most 3 minutes. Teacher का claim है कि maximum 3 minutes लगते हैं. At most 3 minutes. But her students believe that median time is more than 3 minutes. This is the belief of the student. A random sample of 10 students is taken. Check teacher's claim. So, beta, this is a sample of students. So, we will go according to what students believe. That is what we want to prove. So, we want to prove that the time taken is more than 3 minutes. We will prove this. So, my alternative hypothesis will be that the median is more than 3 minutes. So what will be null? Less than equal to 3 minutes. So the reverse of it will become the null hypothesis. That's it. Read the next question. A miling process currently produces average of 3% defectives. You are interested in showing that a simple adjustment on machine will decrease P. So I want to decrease P below 3%. So what do I want to prove? P should be less than 3%. What is 3%? 3 by 100. 3 by 100 is 0.03. So I want to prove that P should be less than 0.03. This is my alternative hypothesis. So what will be null? Greater than equal to 0.03. So this becomes my null hypothesis. Okay. Come to the next question. The average weekly earning for female is 670. Do men in the same position have weekly earning higher than women? So when I'm checking that it is higher than women, that is what I want to show. So my alternative will be that it is higher than 670 and my null will be the reverse, that it is less than equal to 670. Okay. Come to the next question. 60 BTech computer science students have found average of 63.6. 50 BTech mechanical students have mean height of 69.5. So इनका mean height computer science students का 63.60 है. Let us represent computer science student mean height by mu1. इनका average height mu1 है. And 50 BTech mechanical students have mean height of 69.51. तो mechanical students को, let me represent this by average height by mu2. What would you conclude that mechanical students are taller than the computer science students? तो मुझे क्या prove करना है कि mechanical students, मतलब इनकी जो average height है, that means mu2, taller, matlab it is greater than the average height of computer science student than mu1. So which means that beta mu2 minus mu1 should be greater than 0 or mu1 minus mu2 should be less than 0. So we can go ahead and we can say that this is what I want to go ahead and prove. So whatever you want to prove will become your alternative. So the reverse of this will be your null. You can take equal to sign, yes. But usually when we write the reverse of this, it should be okay to take the less than also. So many books will write like this also, that null is just this and alternative is this. But we know that if my alternative is not accepted, then it is not the case that it will only be 670. It can be a little less than 670 also. But yes, both ways are correct for writing null and alternative. Okay. Now, let us talk about something which is known as simple and composite hypothesis. But many people are mistaken that a one-tail hypothesis is called simple and a two-tail is called composite. ये एकदम गलत है. No. The definition of simple and alternative is very simple and composite is very different. So what is a simple hypothesis? A simple hypothesis is any hypothesis where I am able to uniquely define my probability density function. And a composite hypothesis is any hypothesis where there is no unique probability density function, which means that there are multiple probability density functions that exist. So if you have a unique probability density function, then it is simple hypothesis. And if you have multiple probability density function existing, then it is a composite hypothesis. Let me give you some examples. Read this out. Suppose x1, x2 till xn is a random sample from exponential distribution with parameter theta. So what is an exponential distribution? How would we write that? It used to be written as lambda e to the power minus lambda x. This was the probability density function of an exponential distribution, right? Now it says, is hypothesis theta matlab lambda only, simple or composite? So beta, what will I do? Instead of theta everywhere, I will replace it with 3 because this is what I want to test. So this is replaced with 3 and this is also replaced with 3. You can see that this is clearly a uniquely specified PDF. यहाँ पर मेरे पास एक क्लियर पीडीएफ है कि जैसे जैसे मैं x के अलग अलग वैल्यूज डालती जाऊंगी, I will get unique answers. This is a complete PDF in my hand, which will give me unique answers for different values of x. So it's like saying that you put some value of x, you will get some probability. You put some other x, you will get some other probability, some other x, some other probability. So this is uniquely defined in that sense. There is no missing parameter. X to random variable hai, but other than x, nothing is a missing parameter, and therefore we can say that this is uniquely defined. If this is uniquely defined, it means that it is a simple hypothesis. Just wait and compare this with the next example. Same example hai, thoda sa change kiya. See this. I am saying x1, x2 till xn is a random sample from exponential distribution with parameter theta. Ye sab same hai as it is. But now I have gone ahead and I have said that is hypothesis theta greater than 4.5 simple or composite? So beta, what is my PDF? This. Now what is the value of theta? Theta can be anything greater than 4.5. Matlab theta can be 5 also. Theta can be 26 also. Theta can be 50 also. Theta can be any value as long as it is greater than 4.5. So instead of theta, I can put 5. Instead of theta, I can put 6. So it is not uniquely defined now. There are multiple values that theta can take. So it means that theta itself is random in nature. It itself can take multiple values. So we can say in this case that this is not uniquely defined and therefore this is composite in nature. It is not uniquely defined. Take another example. If x1, x2 till xn form a simple random sample from normal distribution with mean mu and variance sigma square, then the null hypothesis that mu is 550, simple or composite. Beta, dobara dekho, what is its PDF? We have done this PDF earlier also. It is 1 by 2 pi sigma square under root e to the power minus half x minus mu by sigma whole square. Now this tells me that mu is 550. It means I must replace this mu with 550. Is there any unknown parameter except x here? Yes. I don't know the value of sigma also. So as sigma will change, my PDF will take multiple values. If sigma is 1, I will get one answer. If sigma is 2, my answer will change. If sigma is 3, my answer will change. So the only variable I have here is not x. There is additional variable, which is sigma. As sigma changes, this PDF will change. So there is not a unique value. So it becomes a composite PDF. So again, I can say that this is a composite hypothesis because there are two unknowns. X ka unknown hona is fine. But this sigma is also unknown. And as sigma changes, my PDF will take different values. So it is not unique and therefore it is a composite hypothesis. Now, just change this question. Suppose we want to test that sigma is 135. Mu is 135. But we are given that this sample has variance of 25. So I know that if its variance is 25, it means that sigma is 5. So now sigma is known to me. This sigma is 5 here, sigma is 5 here. This mu is also known to me, it is 135. Now only variable left is x. It is uniquely defined for different x's. Nothing else is changing. So it becomes a simple hypothesis. So simple hypothesis basically means that it should only have one variable component, which should be the x component. Everything else should be, completely defined, uniquely defined. It should be definite. It should be given to you. But a composite hypothesis is one which will not be uniquely defined. That's the difference between the two. Now, let me talk about type 1 and type 2 error. Try to understand the following example. Let's say that, you are not feeling well and you go ahead and you get yourself tested for COVID. Now, there are 4 things that can happen. You didn't have COVID and the test told you that you don't have COVID, right? The second can be that, what about uniform beta? Here, what will uniform do? That is what you're asking. So yes, if it is a uniform distribution, it will be between A to B now. So now it depends. What is your null hypothesis in that case? What do you want to test there?
Ma'am, it would be simple or it would be composite. Just wanted to check.
It would be simple as long as I know the values of A and B, in which it is defined. If I know that, it will be simple. So the point here is that a uniform distribution will never have, something that is uniformly distributed, you will have all information about it. So if I define the fx is clearly defined as b minus x upon b minus a. So the only variable unknown to me anyways is x. Otherwise, I know everything about this uniform distribution, right? And if I go ahead and I define even its mean, I know it is a plus b by 2. So yes, if a and b is known to me, which will be the case, it will always be a simple distribution or a simple hypothesis. Okay. So now let's say that you didn't have COVID and the test also showed you didn't have COVID. You had COVID and the test also showed you have COVID. This is fine. These two cases are fine. You didn't have, it showed you don't have. You have, it showed you have. But there are 2 other things that can happen. One can be false positive. It means you didn't have, but the test showed you had. This is called as type 1 error. You didn't have COVID, but the test is telling you you have COVID. It's a false positive. And the other can be you had COVID, but the test is saying you don't have COVID. So you actually have, but this test says you don't. This is false negative. It is giving you wrong negative report. Negative दे रहा है, but it is false. यहाँ पे ये positive दे रहा है, but it is false. This is called as type 2 error. So type 1 error is basically a false positive error and type 2 error is a false negative error. So there are two things that we want to understand in this case. If my null hypothesis, suppose I go ahead and I write my null hypothesis in this case, is that I don't have COVID. And my alternative is what I want to prove. मेरे दिमाग में कि I am not feeling well, so I have COVID. So I have COVID. So supposedly that the test tells me that I have COVID. So I have rejected null and I have accepted or not rejected alternative. So I have gone for alternative. So I have rejected null and I have gone for alternative. But this test was wrong. I actually didn't have COVID. So when you have rejected null, you rejected this statement, but this statement was true. This is where you have made an error. You rejected it. You said you don't have COVID. But you actually didn't have COVID. The null statement was actually true. That means you are making an error. So this is the error which is called as type 1 error. Okay. So let's read this again. What are we saying? We are saying that you can go ahead and you can have two possible outcomes. Either you will reject null, either you will not reject null. या तो null को reject कर दिया या मैंने null को reject नहीं किया. Now, this is followed by the fact that null can be true or null can be false. So if I want to make a matrix, it's like this. Here I am saying that I am rejecting null. Here I am saying that I am not rejecting null. Rejecting null means you're going for alternative. You're accepting alternative. Here I am saying null is true. And here I am saying null is false. Right? If null is false and I am also rejecting null, तो ठीक है, I am doing the right thing. It was false, I rejected it. If null is true and I am not rejecting it, वो true था, मैंने उसको reject भी नहीं किया. I am accepting it. Not rejecting means accepting it. So it was true and I am going for it. That's correct. But if it is true and you are rejecting it, it means you are making an error. And if it is false, but you are not rejecting it, it means you are making an error. So when are you making error? When it is true, but you end up rejecting it. Or when it is false, but you end up not rejecting it. You should have gone for alternative. You should have, because it is false, you should have gone for alternative, but you went instead for null. So this is when you are making an error. Now, in this error, what we are saying that these two errors have names. One is called a type 1 error. The other is called as type 2 error. So type 1 error are the errors which are false positives. And type 2 error are the errors which are false negatives. But usually in stats, we don't use the word accept. A statistician will always use the word reject. So we will either say don't reject or reject. Because rejecting does not mean acceptance. Just because I rejected something does not mean I will accept the alternative of it. So we will say that we either reject something or don't reject it. But in your mind, if you feel comfortable, you can use accept. But as a statistician, they will not use the word accept. Okay, fine. So now, again, please let's go ahead and see this. So when my null is true, but I am rejecting null, that means it's like this. When I don't, so null means, null was saying that you don't have COVID. So when you don't have COVID, but you rejected it. So you said that your test said that you have COVID. So your test gave a false result, false positive result. Then that is a type 1 error. When your null is false, that means you actually have COVID. But you're not able to reject null. That means you're going for you don't have COVID. So your test is not able to give you enough proof. The test is saying you don't have COVID. But that is false. You actually have COVID. So it's a false negative. That is type 2 error. So false positives are called as type 1 error and false negatives are known as type 2 error. It will be very clear once I go ahead and I do a numerical on this. Okay. Okay, beta. So let me explain this again. So type 1 error says that you are going ahead and you are rejecting null. Null is true. जो भी null की statement है, that is true. तो जो चीज true है उसको reject नहीं करना चाहिए. But if you reject null, when it is true, you are rejecting null. When it is true, that is called as type 1 error. Type 2 error is saying, I am not rejecting null. Matlab, I am going with null. If in your mind you find accepting null better, to likho accepting null. So I am accepting null, but null is false. So that is called as type 2 error. But null is false. So if I have to write mathematically, type 1 error is when you are rejecting null, but null is true. Type 2 error is when you are accepting null, but null is false. Null अगर false है, तो क्या true होगा? Alternative true होगा. तो इसको हम कैसे लिख सकते हैं? This can also be written as that I am accepting null, but alternative is true. This can also be written like this. This is very, very important. Try to understand this carefully. So type 1 error कह रहा है that you are rejecting null, but null is true. ये एकदम null सही है. जो भी null की value दी हुई है वो ठीक है. But you end up rejecting it. This is called type 1 error. Type 1 error की जो probability है, probability of rejecting null when true, that is called as alpha. Type 2 error is what? It is saying you are accepting null. आपने null को माना वो ठीक है, but actually it is false. So if null is false, it means alternative is true. तो जब alternative true है, but you are going for null, that is called as type 2 error, which is beta. So alpha and beta calculation is very, very important. Now, there is another term which is used. So alpha is also called as size of test. And beta को अगर हम 1 से subtract कर दें, that is called as power of test. So in exam, they can ask you 4 things. Find out type 1 error, type 2 error, size of test, and power of test. So if they ask you type 1 error, I will teach you कैसे निकालना है, अभी हम देखेंगे. But if they ask you find out type 1 error, it means you have to find probability of rejecting null when null is true. If they ask you size of test, तो same ही चीज है. You're finding the same thing. If they ask you type 2 error, it means you have to find beta. And if they ask you power of test, it means you have to find 1 minus beta. Now, in order to find type 1 and type 2 error, you need to go ahead and you need to have something which is known as a critical region. A critical region basically defines that region where you reject something. So for example, let me just draw a normal distribution. Let's say I am saying that, if my mean value, it lies in the extreme 5% values, I will reject my null in favor of alternative. So extreme 5% means I draw 2.5% area here and I draw 2.5% area here. And I say, you know what? If my value will lie in this region, whatever value I calculate, if that value will lie in this region, then this is my rejection region. So I will just reject it. This is my rejection region. So when I am able to define what my rejection region is, मतलब मैं null को कब reject करूंगी, मैं किसी भी चीज को कब reject या accept करूंगी, when I define that. Like for example, I say, you know what, whenever x is greater than equal to 4, I will reject the null. So whenever I define some condition as to how I will reject the null, that is called as my critical region, and this will always be specified to you in the exam. They will tell you what is your critical region, where you are going to reject it and where you're not going to reject it. That will be known to you. Now, just think about it. Look at this diagram, But this is my null hypothesis. This is my alternative. Null or alternative की values अलग होती हैं, so this is my alternative hypothesis. A null hypothesis rejection region is this. ये critical region मैंने बना दिया. I just said that this is my rejection region. Now, what is type 1 error saying? Type 1 error is saying that you are rejecting it. You are rejecting the null. That means you are coming in this region. But null is true. So rejecting when true. So null true है. मेरे को alternative में नहीं जाने की जरूरत. I should be going towards null. This is true. ये जो value बता रहा है वही सही है. But I have rejected it. I have put in the rejection region. So this is how we graphically show type 1 error. That this is my null. This is the acceptance region of null. This is the rejection region of null. I have put it in the rejection region, but it is true, but it is correct. So this is type 1 error. Let me give you one question for it, and then we will come back to this diagram. So see here. Given the probability function, you are given this function 1 by theta, x is between 0 to theta, and it is 0 elsewhere. And you are given theta is, okay, but I will explain this diagram after this question. It will make sense to you. Just see here. So I am saying that your null hypothesis says that theta is 1. And your alternative is saying that theta is 2. दोनों की एक value दी हुई है. Theta is 1 and theta is 2. This is your critical region. So it says, whenever your x is greater than 0.5, I will go ahead and I will reject my null. This is how this critical region is defined. Okay. So when will I reject it? Go back to that diagram. Whenever x is greater than 0.5, ये 0.5 है. Whenever x is greater than 0.5, if I am here, then I am saying that I will reject my null. So this is my rejection region. Rejection region is defined such that x is greater than 0.5. Now, it is asking you to find type 1 error. So what is type 1 error? Type 1 error is the probability that you have rejected null given null is true. Given null is true. So beta, if null is true, तो theta की क्या value होनी चाहिए out of this and this? This, because null is true. So the value of my theta should be 1 because null is true. So I have to take the value of theta at null. But I have rejected it. Rejected it matlab ki I have assumed that it is greater than 0.5. I have put it in the rejection region. So I am saying rejecting null. Kab reject karte hain null ko? It has defined for me the critical region that I will reject it when x will be greater than 0.5. So I am rejecting when x is greater than 0.5, but null is true. So, but my theta takes the value 1. This is how I have defined the probability. So, if theta takes the value 1, so beta, is PDF ko I can rewrite it. And how can I rewrite it? So, I know now that theta takes the value 1. So instead of theta, I will put 1. And here, I will everywhere. Instead of theta, I will put the value 1. So what will I get? I will get that my PDF is 1 when x is between 0 and 1 and 0 elsewhere. Now, when am I rejecting it? I am rejecting it in this region when x is greater than 0.5. So अगर मुझे probability निकालनी है, I must shade this region. I must find the area. Area from 0.5 to what? What is the maximum value x can take? X can be between 0 to 1. So maximum value x can take is 1. So I will go from 0.5 to 1. 1 dx. Because my PDF that I have in this case, it is just this 1. Sirf ye 1 hi to hai mera PDF ab. So I will just integrate it and I will get x between 0.5 to 1. And that will be the answer to this question. You can just integrate. Right? Fine. There's answer. So it will be 0.5. So try to see this, what we are doing. Ek bari dobara dekhte hain. I am saying that my type 1 error is when I am the probability of rejecting null when true. So this says that you are rejecting null. This says that null is true. So when will I reject null? Well, the question says I am rejecting null when x is greater than 0.5. So here I am saying reject when x is greater than 0.5. But null is true. So what value of null should I take? I will take the value of theta at 1. So I have taken the value of theta at 1. So everywhere, wherever theta existed, I have replaced it with 1. And when I do that, I will get a new PDF. Beta W is my rejection region, critical region. This is rejection region. So W is defined as the rejection region. So I am saying that X belongs to the rejection region. So I am rejecting null, but my null is true. Right? So when you solve this, you will get this as the answer. Now, let's do a similar thing for type 2 error. So beta, what is type 2 error saying? Type 2 error is saying probability of not rejecting null. But null is false. So when null is false, तो क्या true होना चाहिए? Alternative. So this is probability of not rejecting null but alternative is true. तो बेटा when alternative is true तो थीटा की क्या वैल्यू ली जाएगी? What value should I be taking? I should be taking theta as 2. So I now know that this is probability of not rejecting null but theta is 2. Now when will I not reject null? When I am given that the rejection region is x greater than 0.5. So non-rejection region will be what? Non-rejection will be x less than 0.5. Rejection region was what? X greater than 0.5. So non-rejection region will be what? X less than 0.5. Given theta is 2. This is the diagram for this. कि क्योंकि मेरा alternative true है तो मैं अपने alternative hypothesis में हूं. I am saying that x is less than some value. X is less than 0.5. But my alternative is true. So I am taking the value of the alternative. Now again, I will go to my this function. And everywhere, instead of theta, I will plug theta as 2. Can x be less than or equal to? Yes, it can be. Because beta, this is continuous, na? So equal to will not make a difference. Correct. It can be less than or equal to. Both. Okay. So now I will go ahead and I will put theta as 2. So if I put here 2, what will I get? 1 by 2. X is between 0 to 2. Theta की जगह पे 2 लिखना है. And 0 elsewhere. This is my PDF now. Half. And x is defined between 0 to 2. अब वापस यहाँ पे आते हैं. So मेरे को क्या probability निकालनी है? That x is less than 0.5. That means it is between 0 to 0.5. What is my PDF? I have defined it as half. क्योंकि थीटा की जगह पे half जा चुका है. So now you can just solve. So this will be x between 0 to 0.5. So it will be 0.5 by 2. So try to understand the definition. अगर definition समझ में आ गई, you can solve any question. Try to see what we are doing. When I am asking you to find type 2 error, it means you are not rejecting null when null is false. Not rejecting null when null is false. So not rejecting null when null alternative is true. अगर null false है तो alternative true है. So in type 2 error, you will take the value of the alternative. And in type 1 error, you are saying rejecting null, but null is true. So you will take the value of null, not alternative. जो value लेनी है यहाँ पे, that is of extreme importance. Let's take the second part of this question. So this says that x is between 1 to 1.5. This is your critical region. मतलब the way that you reject something. When will it be rejected? It will be rejected when x is between 1 to 1.5. फिर से देखते हैं. What is type 1 error? Probability of rejecting null given null is true. That means, beta, probability of rejecting null given theta is at 1. Null is true, मतलब theta की value 1 पे ली जाएगी. So when I take the value of theta at 1, what is the PDF I am getting? Everywhere I will put 1 here instead of theta. So the PDF I am getting here is that when x is between 0 to 1, the probability is 1. And when x is anywhere else, the probability is 0. अब देखो यहाँ पर. What do I have to find? I have to find probability of rejecting null. When was I rejecting null? When x was between 1 to 1.5. But when x is between 1 to 1.5, what is the corresponding probability I will have? 0. Because this is defined in a way that it takes the value 1 when x is between 0 to 1. But between 1 to 1.5 or anywhere else, the probability will be 0. So what will be the probability of this thing? The probability will be 0. So this is very tricky. You have to see this. Okay, I plugged in theta as 1. When I plugged theta as 1, I got a particular PDF with me. This is my PDF that I have got. This PDF says that when x is between 0 to 1, its probability is 1. But I have to find the probability that x is between 1 to 1.5. So uska probability will be 0 because it is 0 elsewhere. So that will be the answer in this case. Now just take the next one. So if I have to find the type 2 error, so ye bhi karte hain ek bari. So again, we will start with the same thing. So what is type 2 error? Probability of not rejecting null when null is false. Every time you have to write this thing down. So probability of not rejecting null when alternative is true. Alternative ki theta ki value was what? 2. So my function defined is with x as it is and theta as 2. Now I am not rejecting null, beta. So if I am not rejecting null, it means that when I am not rejecting null, it means that it has to be in the non-rejection region. So rejection region kaise defined tha ab is case mein? That x is between 1 to 1.5. So what will be non-rejection region? That either x is less than 1 or x is greater than 1.5. Either x is less than 1 or x is greater than 1.5. Yehi do region defined ho jayenge. So less than 1 means what? From 0 to 1. And greater than 1.5 means what? From 1.5 to. This will be the answer to this question. You can solve this. So read the definition properly. If we understand the definition, then the questions can be solved. Let me take few more questions. We have done this. Read this question, huh? X greater than equal to 1 is the critical region for testing theta is 2 and theta is 1. You are given this probability density function, theta e to the power minus theta x. Obtain type 1 error and type 2 error. Achha, just one last thing, beta. Once you find a type 2 error, then 1 minus type 2 error will be the power of the test. So you can also find the power of the test. Now read the question. So how is my rejection region defined? Kya hai mera rejection region? X greater than equal to 1. X greater than equal to 1. This is my rejection region. What will be type 1 error, beta? Probability of rejecting null. Ye rejection tha. Given null is true, so null ki kya value lenge? Theta equal to 2. So you are rejecting null. This is your rejection region. But null is true. So theta equal to 2 is true. So in your function, what will you put the value of theta as? You will put the value of theta as 2. So your probability function, it will become 2 e to the power minus 2x. And how do I have to solve, beta? My probability of x is for all x greater than equal to 1. So this must be integrated between 1 to infinity. And this will be my type 1 error. So you can just solve this. 2 will come out e to the power minus 2x by minus 2 between 1 to infinity. Right? So basically, ये वाला aspect is easier. It's just integration. Understanding the definition is important. So type 1 error is saying rejecting null when null is true. So null की जो हम value लेंगे, the value of null that I will be taking will be this, but I will be finding its probability in the rejection region. So let's see this now. So this is what I have done. Rejecting null, that means it is in the rejection region, but null is true. If null is true, then my theta is at 2. Rejection region is x greater than equal to 1. So from 1 to infinity, I am integrating this PDF such that theta was taken at 2. So everywhere theta was replaced by 2. Now what is going to be type 2 error beta? Not rejecting null. Given null is false. So if null is false, alternative is true. So not rejecting null. Given alternative is true. So alternative की value लेंगे. What is the value of alternative given here? That theta is 1. The value of alternative is that theta is 1. So in this function that I have here, I will be going ahead and I will be taking the value of theta as 1. So 1 e to the power minus 1x. So e to the power minus x. So this will be my PDF. And I am saying I don't want to reject it. So if rejection region was x greater than equal to 1, non-rejection region will be x less than 1. So I am saying not reject null, matlab x less than 1, but alternative is 2, true. So theta का जो value लिया है हमने, we have taken that at the alternative. So I will integrate e to the power minus x, and it will be integrated in the region 0 to 1. Because x was defined between 0 to infinity, and I have to take x less than 1. So when you will integrate this, you will get the answer as this. Power of the test will be 1 minus beta. Put the value of beta and get the answer. Take one more question. It says let P be the probability that a coin will fall head in a single toss. P is given as 0.5 and alternative hypothesis is given as 0.75. Again, beta, here are null, here are alternative. The coin is tossed 5 times and null is rejected if more than 3 heads are obtained. तो पहले हम rejection लिख लेते हैं. So what is my rejection region? How am I defining my W? If the number of heads, let's say X represents the number of heads. So if more than 3 heads are obtained, this is my rejection region. But then what is going to be the probability of type 1 error? So type 1 error is the probability of rejecting null when null is true. So if my null is true, I will take the value of P at 0.5. So I will say this is probability of rejecting null given P is 0.5. Rejecting null means what? Rejecting null means X is greater than 3. So I can simply find this now. But X greater than 3 means what? Ye to binomial hai. So either X is 4 or X is 5 because coin is tossed 5 times. So now I'm saying that I need 4 heads. So out of 5, I need 4 heads into P to the power 4, Q to the power 1. And out of 5, I need 5 heads, P to the power 5, Q to the power 0. Where P is the probability of getting head. And at what probability should I take it? Kya P hoga? P should be 0.5. Because I have to take it at the null value. So I can just put P at 0.5. So Q will also be 0.5. Put and get the answer. So this is what I have done here. So this is my critical region. My region is defined that I will reject when x is greater than 3. And alpha says that probability of rejecting but null is true. So I should be taking it at the value of half. So x greater than 3 means it can either be 4 heads or 5 heads. But the probability of head is half-half. So I will just say that out of 5, 4 heads, half to the power 4, half. Out of 5, 5 heads, half to the power 5, half to the power 0, and you will get the answer. Now, what is type 2 error? So type 2 error should tell me probability of rejecting when alternative is true. So beta, when are you rejecting? When you have less than or equal to 3 heads, right? So less than equal to 3 means what? It can be this. Given, what is the value of alternative? The value of P given to you here is 0.75. So the value of P will be 0.75. So now again I can do this, that I want up to 3 heads. So out of 5, 0 heads, 0.75 to the power 0, 0.25, where did it go? To the power 5. Then out of 5, 1 head, out of 5, 2 heads, and out of 5, 3 heads. You can just plug in these values to the power 1, 0.25 to the power 4, 0.75 to the power 2, 0.25 to the power 3, 0.25 to the power 2. Or you could have done this. 1 minus probability x greater than 3. क्योंकि हमने already value of p तो 0.75 पे plug कर दिया, right? Then you can just take probability of x equal to 4 and x equal to 5. So it is fine to do both ways, but try to understand that if I am finding type 2 error, then I will be taking this at 0.75. I will be taking it at the alternative value. But if I am doing type 1 error, I will be taking it at the null value. That is what is important. Take one more question. So it says x is normally distributed with mean mu and variance 4. Mu is unknown and mu is given to you at -1 at null and alternative is 1. Based on sample size of size 10, we use critical region x1 plus 2x2 till 10x10 greater than 0. What is the size of the test? That means you have to find alpha. What is the power of the test? That means you have to find 1 minus beta. Just take it a moment. Just try to think about it yourself now. Then I will solve it. Just try to do it. So now just try to see. See, the critical region is now defined in terms of the sample only. So what can happen is I am saying that my rejection region W is when x1 plus 2x2 till 10x10, this is greater than equal to 0. This is how my rejection region is defined. Now, what I have to do first is write everything down in terms of this rejection region. So now just try to see, I am saying that my alpha, which is type 1 error, is probability that it belongs to the rejection region, but null is true. So it is rejection region. That means it is greater than 0, but my null is true. So my mu should be taken at the value of -1. But if my mu is taken at the value of -1, it means that now I can say that each x is normally distributed with mean -1 and variance 4. Because I have just taken the value at my null value, and my null value is -1. So when I'm finding alpha, I am saying what is the probability that this entire thing is greater than 0, given that mu is -1. Now this is easy to solve. So let's consider that there is some variable y. And this variable y is x1 plus 2x2 plus 3x3 and so on till 10x10. Now, if I have to find the expected value of y, then I will just put an expectation here and I will just open this up. So it will be e of x1 plus e of 2x2 and so on till e of 10x10. So I can just write this as e of x1 plus 2 e of x2 and so on till 10 e of x10. But each of them, it says they are IIDs. IID means that these are independently distributed and they are identical. So you can just write this down if I forgot to mention that each of them are IIDs. They're independent and identically distributed. So each of them will have the same mean. So each of them will have a mean of mu. So mu, mu, mu till mu everywhere. And I have, because I am taking that the null is true, I have taken the value of mu at -1. So here I can just say that this will be 55 into -1 minus 55. What will be variance again? We know that variance of x plus y is equal to variance of x plus variance of y if x and y are independent. That's the first thing. Secondly, when they are independent, variance of x plus alpha y will be variance of x plus alpha square variance of y. So when I'm finding the variance of this x1 plus 2x2, so their coefficients will become square when they come out. So I will just have variance of x1 plus 4 variance of x2 plus 9 variance of x3, 100 variance of x4 and so on. Now each of them have a variance which is given to us at 4. So I can just put their value, and when I will just put it, I will get 1540 as the answer. So I know now that this is normally distributed with mean -55 and variance 1540. And what is the probability I have to find out? I have to find the probability that y is greater than equal to 0. So beta, we have done this in normal distribution. When we have to find the probability that something which is normally distributed is greater than something, we have to convert this into the z variable. And how can we convert this in z variable? Y minus mean upon standard deviation by root n. This is greater than equal to, this is greater than equal to 0 minus mean upon standard deviation by root n, where this value is called the z variable. Right? This value becomes your z variable. So we can simply say this is the probability z is greater than equal to minus mu upon standard deviation by root n. N is given to you. N is given to you as 10. This is 10 given to you. This we have found out 1540. We know that mean is -55. So I can just put the value of mean. I can put the value of sigma. I can put the value of n and I can solve for it. So when you will, I think here I just forgot to put root n. It should be divided by root n. So when you will go ahead and you will do this, you will get it in terms of z. And from here, it is just Z distribution that we have done when we were doing the normal distribution questions. So this resembles what we have already done in normal distribution. But what is new in this question is how you are going to do this for type 1 and type 2 errors. So I will just go ahead and quickly repeat that for you. So we wanted to go ahead and our rejection region was defined in terms of x's. So it was given to us that we want to show x1 plus 2x2 till 10x10 greater than equal to 0. This is our rejection region. Now, I can't just simply solve for this rejection region. So what we intend to do is, we want to somehow convert this as a single variable, which is normally distributed. So in order to do that, what we do is we define this y such that y is equal to x1 plus 2x2 plus 3x3 and so on till 10x10. And we find out the mean and variance of y. And after finding the mean and variance of y, we say that we want to just check for this y. And my rejection region is defined such that y is greater than equal to 0. So I want to find the probability that y is greater than equal to 0. And because I'm taking that null is true, I will take the value of mu at minus 1. It's a very good question. And believe me, if you look into the past year papers of IIT, these are the type of questions that will be coming in the exam. IIT and ISI will ask you such questions for type 1 and type 2 error. So this is what you have to practice. Okay. So I hope you will be able to do that. Now let's take one more question. So it says for binomial distribution with 4 trials, you are given that null is p is equal to 1 by 3 and alternative is that p is equal to half. Accepting when null when x is less than equal to 2. So again, you can just take, it says you are accepting when this is there. So what will be your rejection region? X greater than 2. Because this is your acceptance region. So rejection region will be x greater than 2. Now what this is saying? I have to find type 1 error. So type 1 error will be probability of rejecting null when null is true. So if my null is true, I will be taking at p equal to 1 by 3. So my p will be 1 by 3. And I am rejecting null. That means my x is greater than 2. So how many trials am I doing? 4. X is greater than 2. It means that x will either be 3 or x will be 4. So out of 4, I need 3 or out of 4, I need 4. And p is given to me as 1 by 3. So 1 by 3 to the power 3 and 2 by 3 to the power 1. 1 by 3 to the power 4, 2 by 3 to the power 0. So that will be your type 1 error. So this is what I have done here. And this will be your answer. Now do type 2 error. So type 2 error is accepting when false. So if it is false, it means that you have to take the value of p at half. So you are saying you need to find the probability x is less than equal to 2, but p is taken at alternative value. That means p is taken at half. So less than equal to 2 means what? That either x can be 0 or x can be 1 or x can be 2. And p is taken at half. So out of 4, 0, out of 4, 1, out of 4, 2, half to the power 0, half to the power 4, half to the power 1, half to the power 3, half to the power 2, half to the power. This will be the answer to this question. That will be your beta. Right? Okay. Take one more. Let x be number of successes obtained in 5 minutes during a Poisson process. It is desired to test the null hypothesis that mu is 2 against the alternative hypothesis that mu is 3. where mu is mean for 5 minutes. And x greater than 4 is used for critical region. Critical region means region of rejection. So when are you rejecting it? You are rejecting it when x is greater than equal to 4. That is when you will reject it. So what is alpha? Probability of rejecting given null is true. So you will take mu at 2. And probability of rejecting means x will be greater than equal to. So we know that a Poisson distribution can be written as e to the power minus lambda, lambda to the power x by x factorial. This is how Poisson is written. And in this case, our mean is nothing but lambda, right? So mean is given at 2. So we can just go ahead and put 2 here. And now I need to have x greater than equal to 4. Matlab 4, 5, 6 till infinity. We don't know the end. So this can be rewritten as, give me a minute here. Sorry, the pen just got discharged. So this can be written as this e to the power minus 2 to the power x by x factorial. Now x greater than equal to 4 is very difficult because it can be 5, 6, 7 and so on. So I can just write this as 1 minus probability x less than 4. Less than 4 means just 0, 1, 2 or 3. So I can just put those 4 values. So this is what I have done here. I have taken lambda 2 and I'm saying x can take the values 0, 1, 2 or 3. So 0, 1, 2 or 3. I've just plugged those 4 values here. So you can just plug values and check. So when you put 0 here, you will get e to the power minus 2, 2 to the power 0 by 0 factorial. When you put x as 1, you will get e to the power minus 2, 2 to the power 1 by 1 factorial. When you put x as 2, you will get this. And when you put x as 3, you will get this. So you can just take this common and you will get this here. Again, if I were to find beta, what will I do? So probability that x is that you are in the acceptance region, but alternative is true. So if alternative is true, it means that I am here. My mu is at 3 and x is less than 4. So this is what I've done here. X is less than 4, but my mu is 3. So in my distribution, e to the power minus lambda, lambda to the power x by x factorial, everywhere lambda will now be replaced with 3. So e to the power minus 3, 3 to the power x by x factorial. Now it's the same. So I want to find x less than 4. It means x will be between 0 to 3. Put 0, put 1, put 2 and put 3 and solve. Now if beta this is beta, then power of test, it will be 1 minus beta. So you can get the answer in this case. I'm leaving this question to you. Just go ahead and solve these 2-3 questions. And I will also be posting an assignment on type 1, type 2 error every year in exam, especially because currently we are preparing for IIT. Some topics are compulsory. They will give you a question on type 1, type 2 error. They will give you a question on maximum likelihood estimator. They will give you a question on probability distributions. So we know that these topics are always asked in exam. And therefore, this will definitely come as a 2-marker question. So you must go ahead and practice these questions. So do the assignment before tomorrow's class, then I will begin with hypothesis testing. Okay. So now, beta, on the basis of this, you can easily identify what your type 2 error diagram is. So what are we saying? I am saying that this is my null. This is my alternative. दोनों का वैल्यू अलग होता है ना. सो जैसे यहां पर नल का वैल्यू है 2 और ऑल्टरनेटिव का है 3. सो आई कैन से दैट नल इज प्लेस्ड एट 2 एंड ऑल्टरनेटिव इज प्लेस्ड एट 3. नाउ आई एम सेइंग दैट आई एम एक्सेप्टिंग नल. मतलब मैं नल, सो अगर ये नल का रिजेक्शन रीजन है, मतलब ये सारा नल का एक्सेप्टेंस रीजन है. दिस इज द एक्सेप्टेंस रीजन ऑफ नल. So I am accepting null, but alternative is true. तो alternative और null की acceptance region में क्या common है? This region. यहाँ पे alternative तो है, but ये null का acceptance region भी है. So this is what your beta is. You are in the acceptance region of null, but your alternative is true. So this region, that becomes your error. Which normal distribution? Which question?
Ma'am, x1 plus 2, x2 plus 3.
Which
Yes,
question
ma'am.
in normal distribution is the doubt? Okay. So what I have done in this case is basically it says that your rejection region is defined as a. So what I've done here is that you can just go ahead and take that, okay, this is my rejection region, x1 plus 2, x2 and so on till 10 x10 greater than equal to 0. This is how my rejection is defined. So what I am doing in this case is I am saying let there be a variable y. And this y variable be x1 plus 2x2 till 10x10. So my rejection region is when y is this is y, this is greater than equal to 0. Now, what I'm saying is that I need to somehow convert this probability in standard normal terms. So what I'm doing here is I am saying, okay, y minus mu upon standard deviation by root n should be greater than equal to 0 minus mu upon standard deviation by root n. So that this becomes my z variable. I want to convert this into a z variable. So I can simply say that probability z greater than equal to 0 minus mu upon standard deviation by root n. But now, to find this probability, ki ye probability kitni hogi of making this error of this rejection region, I need to know what the mean and variance of this y is. Only then I can plug in some values. So then I go ahead and I find back the mean and variance. So it tells me that, okay, my y is x1 plus 2, x2 and so on till 10x10. So in order to find the mean of y, I will find e of y. So it will be e of x1 plus 2, e of x2, so on till 10, e of x10. And each of the x's are the same only. So it will be mu plus 2 mu plus 3 mu and so on till 10. So you will get 55 mu here by adding. Now, what is the value of mu I should take? So none. So type 1 error says probability of rejecting null. I have written the condition of rejection. Given null is true. So I should be taking the value of mu at minus 1. So here I will take the value of mu at minus 1 and I will get minus 55. So this will be the mean of this y variable that I had. Similarly, I need to find this sigma also. That means the variance of y first I need to find out that. So again, I will just use the conditions of the variance. So variance of y will be variance of x1 plus 4 variance of x2 and so on till 100 variance of x10. And I am already given that it follows a normal distribution with mean this and variance this, right? So you just have to go ahead and you just have to plug in these values here and you will get the answer here as 1540. Yes, for the second case, you will take mean at 1. So if I just go back now, you can see here that in the second case, I have plugged mean as 1. Correct. But it will be in the acceptance region. So y will be less than 0. In Poisson distribution, can we not use infinite GP formula? You can use that, but it would be possible. Yes, you can use that. But I think this is easy as long as I just have 3-4 x's to work with. Otherwise, you can go ahead and do that also. But
So, ma'am, in that case, the calculation will become tricky in case we use the infinite GP formula.
ratio. So GP cannot be used. Am I audible now?
Yes, ma'am.
So is it clear now why you cannot use that? GP can only be used if you have a common factor. Here in Poisson distribution, in the denominator, there is no common factor. So you have factorials here. So you can't take any common pattern out here. Okay. Anything else? Any other doubt we have? Part B of question after explanation of critical region. Which question? Tanisha, which question are you referring to?
Ma'am, the first question you did after the critical region. The theta one. I just wanted to see the part B.
Okay. What in exponential distribution? You can unmute and tell me quickly. What in exponential distribution is the doubt?
Ma'am, above this, before this. Yes, this part B. Just the part 2. Ma'am, yes, for this question only. Can you explain the beta for this?
This one?
No, ma'am, just इससे पहले जो question था. इसके just ऊपर जो question.
Are you guys there? What is the doubt?
Ma'am, उसमें मेरे को बस beta वाला, if you can explain once again, then how did we find the beta for that question?
Okay. If there is no doubt, I'll end the session then.
Excuse me, ma'am.
Second error in which question? Is it this question? Is it the next question? Which question are we talking about?
Ma'am, इसके just
this one?
No. The above one. Just इससे पहले है. That's the one.
Okay. So this question is saying that you have to go ahead, and type 2 error is saying what? You should go ahead and accept when alternative is true. So I have taken acceptance region is given to me as x less than 1. So I have just taken my acceptance region at x less than 1. And it says that alternative is true. So theta is taken at 1. So if I take theta at 1, I will get 1 e to the power minus x. That means e to the power minus x. And it says x has to be less than 1 because I have to accept. So it means that x will be between 0 to 1, e to the power minus x dx. So you will just integrate this between 0 to 1. So this will be minus 1 by e to the power x between 0 to 1. That's it. That will be your type 2 error. This is what we have done here. Hi, good afternoon, everyone. In today's class, we are going to go ahead and talk about hypothesis testing. So I'm going to cover 3 kinds of hypothesis testing in today's class. One is going to be a Z test. One will be a T test. And one will also be another kind of Z test, but it will be according to the difference in the means. So in order to start with hypothesis testing, we need to understand that we can divide the entire process in 2 parts. One can be called as a large sample test and other can be called as a small sample test. What is a large sample test? Whenever your sample size exceeds 30, that is called as a large sample. And whenever your sample size is less than 30, that is called as a small sample. So, very simple. If you see n greater than or equal to 30, it is a large sample. If you see n less than 30, it is a small sample. What is n? N is your size of the sample. Size of sample. Now, in your n is greater than equal to 30, then you will use what is called as a Z test. But if your n is less than 30, then you will use what is called as student's t-test. So that is how we are going to go ahead and see. Now, when I talk about Z-test, then Z-test automatically assumes that I have a distribution which is normally distributed. So we are only talking about normal distributions. And why is something normally distributed? Because we have already studied the central limit theorem. And what was the central limit theorem saying? The central limit theorem suggested that if I have a population and out of that I am withdrawing the samples and I am finding the mean of this, then this will be having normal distribution. We talked about central limit theorem in one of the classes. So because of the central limit theorem, CLT, we know that even when it is not, population is not normally distributed, the sample mean will have a normal distribution. So it will always be normally distributed, and therefore we assume that it follows a normal distribution. And what I'm going to deal with today will actually be something where we want to do all hypothesis testing around the sample mean. So because my hypothesis testing will be around the sample mean, we can assume that it is normally distributed. So we can go ahead and say that it is normally distributed. Yes, exactly, beta. Correct. Now there are two things that can happen. The first thing that can happen is that the sigma of the population will be given to you. This is very rare. It will very rarely happen. So if the sigma of the population, sigma means what? Standard deviation. So if the sigma of the population will be given to you, then the formula for Z will be x bar minus mu upon sigma by root n. But this will only happen when sigma is given to you. In 90% of the cases, sigma will be unknown. So when this sigma will be unknown, what will be given to you, beta? You will be given the standard deviation of the sample. So you will not be using sigma here. Instead, you will be using S here. And the formula of Z will be x bar minus mu upon standard deviation of the sample. This is standard deviation of sample divided by root n. Now I want to focus here on something very, very important. If you remember, I did efficient estimates with you. And there I told you that look, whenever we will use the sample variance formula, then that formula will be summation xi minus x bar whole square divided by n minus 1. This is what I told you. Today, I want to distinguish this. This is very, very important. Try to listen to me very carefully. I want to distinguish this today for you. Now just think about it. Beta, a lot of times when we have large sample size, when my sample size is large, in that case, the variance used by the sample is also xi minus x bar upon n. We will not divide it by n minus 1, but we will divide it by n. Now, how do I know whether I have to divide it by n minus 1 or n? In entire hypothesis testing, whenever you will be having hypothesis testing, you will assume whether it is large sample or small sample. I will show you various cases. What I am speaking will make sense once we do the questions. But in entire hypothesis testing, you will assume that the sample variance given already would have used this formula, summation xi minus x bar whole square by n. It would have used this formula. This is what you will assume. ये assumption बहुत important है. Throughout my hypothesis testing, this is an assumption that whatever sample variance is given to me, जो दिया हुआ है, वो इस formula से calculate किया गया होगा. It must have been calculated using this formula. Now, if I have a large sample, then I will use this given sample variance as it is. As it is, I will use it. But if I have a small sample, then I will make some changes to what is given to me and I will show you what those changes are. अभी मैं आपको दिखाऊंगी क्या changes हैं. So let me repeat what I have said. Let's make a note of it. What I am saying is the following. In question, you will be given sample variance. आपको एक sample variance दिया होगा. You will be given some S square. This S square in the background, ये ऐसे calculate किया होगा. xi minus x bar whole square by n. जो भी question में दिया होगा, it is calculated using this formula. Nobody will mention that we calculated using this formula. This is a known fact कि अगर उन्होंने sample का variance calculate किया है, so they have used summation xi minus x bar whole square by n in the question that has been given to you. Now, if this question is about a large sample, matlab this question has given you that n is greater than equal to 30. Then you will use this as it is. जो भी यहाँ वैल्यू दी हुई है उसको as it is हम यूज करेंगे इस फॉर्मूला में. x bar minus mu upon standard deviation by root n. जो हम z निकालेंगे, in that this s will be used as it is. इसको as it is क्वेश्चन की वैल्यू से हम यूज करेंगे if it is a large sample. But if it is a small sample, that means if n is less than 30, then in that case, we must go for something which is called as a t-test. In that, I will not be using this as it is. इसको जो value दी हुई है उसको as it is नहीं use किया जाएगा. It will be modified. How it will be modified, I will show you in a while when I talk about t-test. But abhi ke liye we just should remember that this value will be modified. How? We will talk about it. So for now, whatever sample variance will be given to me, I will use that as it is in this Z test formula. इसको as it is हम इसमें use करेंगे. That is what is important for us for now. So coming back. So if the standard deviation is unknown of the population, then I will go with that of the sample. Now, let us go ahead and take a question. But before that, I also want to talk a bit about this Z table. In 99% of the case in exam, you will not be given Z table. आपको Z table नहीं दिया होगा. You have to remember some values of the Z table that I have written here. What happens when alpha is 5% in two-tail? What happens when alpha is 1% in two-tail? What happens when alpha is 5% in one-tail and alpha is 1% in one-tail? You have to remember these values as it is. You have to remember them. But still, I want to tell you how these values are derived. So this is a Z table. And this Z table, every Z table is based on some shaded region. So when this Z table is drawn, इसका shaded region जो book में दिया हुआ था, that shaded region beta is this shaded region. Only one half it is considering, huh? So you just have this shaded region. this one, sorry, this shaded region, 1/2. Now let me just explain you what this is doing. So let me go to the value 1.96. So I take 1.9 here and I take 6 here. So I go to 1.9 and 6 here. And I get 0.4750. That means that this area is 0.4750. So beta, this total, I know when it is normal distributed, we know we have 50% here and 50% here. So I know that this total should be 0.50. And this table tells me that if my Z value is 1.96, मतलब मेरी Z की value अगर 1.96 है, this is my Z value, then this area, this much area, this is 0.4750. But this entire area is 0.5. So this area, the remaining area that you will get here, beta, this will be 0.5 minus 0.4750. So you will get this as 0.0250. So this will be 0.025. So if I multiply this with 100, it means it will be 2.5% area here. Similarly, if I go ahead and because these are symmetric ना, तो अगर मैं यहाँ पे minus 1.96 लिख देती हूँ, it means that there will be 2.5% area here. So what does this mean? It means that if I am doing a two-tail test, we talked about alpha yesterday. Alpha was the probability of type 1 error. So if I want to go ahead and I want to mark that alpha area such that this Z is 1.96 and minus 1.96 here, I will get this and this together as 5%. 2.5% यहाँ है and 2.5% यहाँ है. मतलब the probability of making error in a way that is 5%. So remaining area कितना हो गया बेटा? 95%. So we call this as 95% confident. Now these values will not, ये table नहीं दिया होगा. It is very difficult to provide table to each student. So such a table will not be given to you. I just wanted you to interpret this table. But what will be given to you will be these values. And sometimes they will not give these values, assuming that a student should at least know these values on their own. Itni values sabko pata honi chahiye. So now similarly, beta, if I go to 1.645, so 1.65 ले लेते हैं यहाँ पे. It gives me 0.45. That means 45% of the area. So that means that this area is 45%. So ये area भी 45% हो गया. So the remaining area will be 10%. So if I have 90% confidence, that means I have alpha is 10%. My level of significance is 10%. Alpha is that type 1 error probability only. Then the corresponding Z should be minus 0.645 and 1.645. So this is another value you have to remember. So Z value will be plus minus 1.645 for alpha is equal to 0.10 for 10% level of significance. Yes, I did it for two-tail only, na beta? Because I am taking it for this and then I am saying this is symmetric. So therefore I am just doubling the area. So it becomes for two-tail. Okay. So these are the values which all of you will remember. Nobody is going to skip on these values. This Z table ki ye 3 value and Z table ki ye for one tail. And for two tail you will remember it. Although we have seen it how to do it using the table, but remember them. Now let me go to a question and things will become clear. So read it out. Consider a random sample of 100. N is greater than 30. I have to use a Z test. So of 100 Indian carpenters. So N is 100. Producing a mean of sample mean of 15. So sample mean matlab ki beta X bar is 15. And standard deviation of 2. So S is given to you as 2. Show that average wage of carpenter is different from, yes, plus minus 1.645, correct. Show that the average hourly wage of carpenter is different from 14. Yes, beta, they were provided. So different from 14 means what? When I say different from 14, it means that they should not be 14, right? So not be 14 means that I have to test the null hypothesis that mean is 14. Remember yesterday we saw how to write the null and alternative, and alternative will be that it is not equal to 14. Let's solve this question together. So what is this question saying? Consider a random sample of 100 Indian carpenters. So it's okay, beta. You can look at these questions with me and try to solve them. I am going to do each one of them together. So the sample size is 100, and mean is given to you as 15 and standard deviation as 2. So what will we do, beta? We will write the null hypothesis, and null hypothesis will be that mean is 14. Why 14? Because population ke liye I am testing it for 14. Beta, what will be my alternative hypothesis? That mean is not equal to 14. Now, my N is 100. This is greater than 30. So I will go ahead and I will use the Z test. And what is the formula of Z test? X bar minus mu upon standard deviation by root n. Beta, what is X bar given to you? X bar is given to you as 15. What is mu given to you? Mu is taken at 14. What is S given to you? S is standard deviation given at 2. What is N given to you? N is 100 and that is given to you as root of 100. So this is going to be 1 upon 2 divided by 10. So this is going to be 10 by 2, which is going to be 5. So beta, you will be able to identify based on the diagram that will be given to you. So as I mentioned, whenever a Z table is given, you are given a diagram in the background. So if the diagram looks like this, then I know that the shaded region is only this much. Accordingly, I did my analysis. If the diagram given to you above Z table is this is the diagram. Then you will know that against 1.96, the area that will be given to you will be 0.9750. मतलब यहाँ पर the value that is 0.4750, इसकी जगह पे 0.9750 will be given. So then I will know that this is a one-tail test and this remaining area is 2.5%. So based on the diagram that will be provided here on top, you can try to make the analysis what this area is representing. With every Z table, you get a shaded area. And on the basis of that area, we need to understand what that area is representing. Here, this says that this is plus 1.65 or plus 1.96. And the area given is 0.4750. So, matlab, ye jo area hai, it tells me that this, because it is less than 0.5 now, so it has to be only on one side and it has to be 0.4750. So I shaded this region. So it will be given to you. This diagram will be provided in the Z table itself, on the basis of which you will make this analysis, what the Z table is depicting. Okay. Okay. So beta, I am using the formula of S only. Now, the point is that S is an unbiased estimator of sigma. So when we write the initial formula, we write it with sigma only. I will always say that my actual formula is x bar minus mu upon sigma by root n. And then you can, I mean, for you, you're doing an MCQ, you don't have to write it down. But usually when we do theoretical questions, we will write this down. That since sigma is unknown, we will use S. So I am using S therefore. So sigma is not given to me. So instead of sigma, I am using the standard deviation of the sample because it is an unbiased estimator of sigma. So therefore, here I have replaced it with S. And after replacing it with S, I have been able to go ahead and I have been able to put the value as 2. So I will get this as 2 by 10. So this will be. Now, try to understand, this is my Z calculated. My Z calculated is 5. What will be my Z tabular? Well, we know when we go to the table, I will not go to the table now because in exam table may not be given to me. But I know that this is asking me at a 5% level of significance. This will be given to you. So based on the level of significance, we can say that using a two-tail, we know that Z tabular is plus minus 1.96. So what I will do is try to see here. I have a diagram here. This is 1.96. This is minus 1.96. Anything after 1.96 or before minus 1.96, this is called your rejection region. Now, what is the value of Z that I have achieved? I have achieved the value of Z, which is 5. So since the value of Z is 5, 5 is lying here, right? 5 lies here. So it is clearly lying in my rejection region. This is clearly lying in my rejection region. So therefore, I should be rejecting null in favor of alternative. So what I am saying that because Z calculated, we can just say this here like this, that Z calculated is greater than Z tabular. My calculated value is 5 and it is more than my tabular value. You will always check them in absolute cases. That means that it would have been in your rejection region. So therefore, you will reject null in favor of alternative. Yes, but a sigma only is standard deviation. Yes, they are the same thing. We are taking 2.5 on both sides because it is a two-tail test. Yes, because this is not less than. So this is a two-tail test. So if it is a two-tail test, I will go ahead and I will take this value. For 5%, I will take this value plus minus 1.96. That is exactly what I have gone ahead and taken. Okay. Let's take one more question. Read it out. It says the average weekly earning for female social worker is 670. So, do men have more than women? Your sample size is 40. So, beta, n is greater than equal to 30 because n is given to me as 40. So, I will use a Z test. Male mean wage is 725. So, male ka mean wage is given to you as 725 and the standard deviation is given to you as 102. Now, the question is asking, beta, we did this yesterday, right? You use a two-tail test when I taught you writing the null hypothesis, alternative hypothesis yesterday, right? In that, I explained everything. This is what we did yesterday, right? What is a two-tail test? What is a one-tail test? How to write them down? We did all these examples. It's based on that only. So I am just repeating the same questions that I did yesterday. It's just that today I am taking the full-fledged question. So we discussed this yesterday, whether we are using a two-tail test or one-tail test. Okay.
Ma'am.
Yes.
Ma'am, I can understand the formula that why we're using that. Sigma is known, then also we're using the formula of unknown. Can you explain once again?
Okay. So, beta, I am saying that when sigma is unknown, then we are using S. But the formula is very similar. So, I have x bar minus mu. If sigma is known, I will use this. When sigma is unknown, I will just replace sigma with S. That's it. This represents
S are different. You have
this represents the standard deviation of sample. This represents the standard deviation of population. Standard deviation of population may not be given to you. 90% of the times nahi diya hoga. So if standard deviation of population is not given, in the question you will be given standard deviation of sample. So instead of sigma, you will be using S. S represents the standard deviation of the sample. That is it. That's the only difference.
Okay.
अभी के लिए और कुछ भी नहीं है. It is a large sample test. In large sample, बहुत ही simple होता है. Sigma नहीं दिया होगा, but sample का standard deviation दिया होगा. Sample के standard deviation को S बोलते हैं. S सिग्मा का एक एफिशिएंट एस्टिमेटर है. S सिग्मा को अच्छे से रिप्रेजेंट कर सकता है, तो हम सिग्मा को S से रिप्लेस कर देते हैं और हम सैंपल डिविएशन सैंपल का स्टैंडर्ड डिविएशन यूज कर लेते हैं. दैट इज इट दैट वी आर डूइंग हियर. ओके, सो you are given that n can be greater than equal to 30 because n is 40 here. So again, this is yesterday's class only. So we have that the null hypothesis is mu equal to 670. And then it says, do men have more than women? More than women means I will take greater than 670. So it becomes a one-tail test. Now what will be Z? Again, the formula of Z will be x bar minus mu upon standard deviation by root n. Standard deviation of population. But ये नहीं दिया हुआ है. So I will use that of the sample. Sample ka it is given to me as 102. Root n is given to me as 40. X bar is given to me as 725. And mu is given to me as 670. This is exactly what I will go ahead and do. So when you will do this, you will get the answer as 3.41. Now beta, it is saying check with alpha at 1%. And it is a one-tail test. So how will I take alpha? I will take alpha at 1% under one-tail test. मतलब मेरी जो Z की वैल्यू होगी वो होगी 2.33. That is why I want you to remember these 5-6 values. So it will be 2.33. So which means that, beta, if I were to draw a table and if I were to shade 1% area here, तो ये जो value होती, this would have been 2.33. जो 1% area और 99% area को अलग करेगी, that value will be 2.33. And this will be my rejection region. ये मेरा rejection region. And this will be my non-rejection region, 99%. Why 99%? Because it is given to me that alpha is 1%. So I need to only shade 1% area. Why am I not shading on both the sides and only one side? Because it is a one-tail test. So I have to only shade on one side. Now my Z calculated, but that is coming as 3.41. So my Z calculated, that is 3.41. So Z calculated is more than Z from the table. So I am in the rejection region. So if I am in the rejection region, I will reject null in favor of alternative. और ऑल्टरनेटिव क्या कह रहा था कि मेल्स की वेज फीमेल से ज्यादा हैं, उनकी वेजेस में डिफरेंस है. सो आई विल गो फॉर द ऑल्टरनेटिव. दिस इज व्हाट आई विल गो फॉर. बेटा, standard error is simply this value together. This together is called as standard error. Again, we did this in one of the classes, right? That the formula of standard error is simply S by root n. So if you are given standard error, it means you are given this as a whole. So in the denominator, you don't have to then divide it by root n or do anything. ये पूरा का पूरा denominator ही दिया हुआ है. If they say that standard error is given to you. Okay. Okay. Take the next question. It is hoped that newly developed two decimal places. Fine. Yes. It is hoped that newly developed pain reliever will reduce pain. The old drug average time is 3.5 minutes and the sample mean is given to you as 3.1 for the new drug and sample standard deviation is given to you as 1.5 minutes. Check at 5% level of significance. So beta, ये क्या बोल रहा है क्वेश्चन कि आपके पास एक न्यू ड्रग आया है और न्यू ड्रग पेन जल्दी ठीक कर देता है एज कंपेयर टू ओल्ड ड्रग. सो व्हाट विल बी माय अल्टरनेटिव हाइपोथेसिस? आई वांट टू रिड्यूस द टाइम बिलो 3.5 मिनट्स ना, जितना पहले लगता था उससे कम टाइम लगना चाहिए. दैट इज व्हाट आई वांट टू प्रूव. सो माय अल्टरनेटिव हाइपोथेसिस विल बी mu less than 3.5. And what will be my null? Null can be mu greater than equal to 3.5 or just equal to 3.5. But I want to prove that the time has been reduced. So that will become my alternative hypothesis. How can we go ahead and write Z? Z will be again x bar minus mu upon standard deviation by root n. And if sigma is unknown, population की value इसमें नहीं दी हुई है, so it will be x bar minus mu upon S by root n. What is the mean of the sample given to you? 3.1. So I will use this as 3.1. What is the value of standard deviation given to you? 1.5. So I will use this as 1.5. What is the value of n given to you? N is given to me as the old drug average time is this sample mean. Not sure if I just forgot to write it. You can just write that the sample is taken for 50 units. So sample size is given to me as 50. So I will use root 50. And what is the mean of the population? पुराने drug का कितना time हमने use करना है? What is the null value I have? 3.5. So I will check the null at 3.5. When you will calculate this value, you will get the value as minus 1.866. Again, beta, this is a one-tail test. This is a one-tail test. So when I will check at 5% level of significance, I have to compare it with the one-tail value. So what is the 5% level of significance at one-tail value? It is this, 1.645. ये हमेशा प्लस माइनस में चलते हैं. So it is 1.645 under 5%. So now in this question, this is like this, huh? Because ये negative है, I will draw it on the negative side. So minus 1.645. Beta, this is my rejection region. This is my non-rejection region. And I have minus 1.866. मतलब इधर. This is drawn at 0. तो ये यहाँ से negative जा रहा है, यहाँ से positive. So minus 1.866 will be here. So it will be in the rejection region. Or in simple words, the Z that you calculated in absolute values is greater than your Z tabular. 1.866 is more than 1.645. Whenever Z calculated will be more than Z tabular, you will reject null in favor of alternative. So what was your alternative saying? That the time taken by the drug has been significantly reduced, and that is actually correct. So therefore this is correct, that the time has been reduced. It is easier to check in absolute term. मतलब absolute में नहीं भी करोगे तो भी ठीक है, क्योंकि देखो हमने जब negative में check किया तो भी ठीक आ रहा था ना कि ये rejection region में fall कर रहा है. But it is easier when you check in absolute terms, because then you just have to work with greater than sign. So check in absolute terms, it will be better. Okay. Now read the next question. The daily yield for local chemical plant has averaged to 880 tons. ये general statement है, मतलब ये population की statement है. We want to check if this average has changed. Now you select 50 days sample and you find the mean as 871 and standard deviation as 21. मतलब ये sample की बारे में बात हो रही है. Again beta, I will use the Z test. So why Z test? Because sample size is 50, which is more than 30. So what will be my Z test? X bar minus mu upon standard deviation by root n. X bar is given to me as 871. Mu is given as 880. Standard deviation is given as 21. And sample size is given to me as 50. ये value डाल दी. When you will solve this number, you will get the answer as minus 0.03. Now again, for 5% level of significance, we have got that the Z calculated in absolute terms is 3.03. And the Z tabular, that is beta 1.96. From the table. Why? Because this is a two-tailed test. So I am using 1.96. So Z calculated is more than Z tabular now. So again, you will reject null in favor of alternative. So you will say that the average is not 880. It is different from 880. इसको डिपिक्ट भी कर सकते हैं. आपका जो वैल्यू आया है वो माइनस 3.03 आया है और Z की जो वैल्यू है वो 1.96 है. And it is a two-tailed test. So this is 1.96. This is minus 1.96. This is your rejection region. And your value that you calculated वो आ रही है minus 3.03. So it is lying in the rejection region. So you will reject the null in favor of alternative. Now, but there is something which is known as confidence interval. Just try to see. I gave you a formula for Z. And what is the formula of Z that we have got? X bar minus mu upon S by root n. Beta, this S by root n, this is called as standard error. So I will replace this with standard error. I will call this as standard error. Now, we know that the value of Z that I get, it can both be positive or negative. मतलब हम हमेशा plus minus 1.96 plus minus 1.645 दोनों लिख रहे हैं ना. It can be on both the sides. So can I just say that whatever value that I get, it can either be plus or it can be minus. दोनों हो सकती हैं, plus भी हो सकती है, minus भी हो सकती है. So beta, plus minus Z, I can take standard error here into standard error will be x bar minus mu. So mu can be x bar plus minus Z into standard error. This actually, when we calculate it like this, तो मेरे को एक x bar से इस अमाउंट को कम करके वैल्यू मिलेगी और एक x bar से इस अमाउंट को ऐड करके वैल्यू मिलेगी. So this is actually called as the confidence interval of mu. The confidence interval of mu says that mu will lie between Z into standard error and x bar plus Z into standard error. Mu इनके बीच में लाई करेगा. Mu की जो वैल्यू होगी, जो population mean की वैल्यू होगी, that will lie in between these two values. Now, this confidence interval approach is another way of checking hypothesis testing. So, for example, let's say that you go ahead and you have a null hypothesis which says mu is equal to 0. And your alternative hypothesis is mu not equal to 0. Suppose ये आपका null or alternative है. Now what you do is, you calculate this confidence interval. And when you calculated this confidence interval, आपकी mu की जो range आई है, that range is between -4 to +3. So does this range include this 0? Yes, because this says that mu can be between -4 to 3. So it includes this value of 0 na. So we can say that null cannot be rejected. But suppose when you calculate this confidence interval, it comes like this. -4 to -2. Then does this include 0? No. So then you can go ahead and you can say that null is rejected because it does not contain this value of the null. It does not contain this 0. This confidence interval does not contain 0. Let me show you a question on this. So try this out. Read it out. A sample size of 100. So n is given to me as 100. Is drawn from a population. Standard deviation is given to you as 10. If sample mean is 62.15, find the 99% confidence limit for the mean of the population where the value of Z is given to you as 2.58. So Z is 2.58. So what do I have to do? I have to go ahead and I have to find the range of mu. So what will be mu, beta? Mu will be in between x bar minus Z plus Z into standard deviation by root n. So 10 by root n. Standard deviation by root n. What is x bar given to you as? 62.15. What is Z given to you as? 2.58. This is 10 divided by 10 mu, and this is 62.15 plus 2.58 into 10 divided by 10. So this will be 62.15 minus 2.58, and this will be 62.15 plus 2.5. You can calculate these values. You will get the values as 59.57, 64.73. 59.57, 64.73. ऐसे कुछ values आपकी आ जाए. Now, if my null hypothesis is that, next question says, test the null that mu is 64. Is 64 included in this interval? Yes. So if my null is that mu is 64 and my alternative is that mu is not equal to 64, I can reject null in favor, I cannot not reject null because 64 is included in this interval. This is how the confidence interval approach can be used. Let me take one question from the background. So I will take this question and show you the same thing again. So quickly, let's do the same calculation for this question. This says, but we will reject null if the null value is not included in the interval. यहाँ पे अगर suppose मेरा confidence, अगर if my null hypothesis would have been mu is equal to 68. So 68 is not included in this confidence interval. ये 59 से 64 तक है. So I would have rejected the null in favor of alternative. Let's take this question. This says, the daily yield for local chemical plant has averaged to 880. ये मेरा null or alternative as it is. Now this says that we have the mean as 871, standard deviation as 21, n is 50, and 5% level of confidence. So my mu can be between x bar minus z into s by root n, x bar plus z into s by root n. What is my x bar, beta? X bar is given to me as 871. So 871, 871. What is z given to me as? Z I will take at 5% level of significance. और उस z की value क्या होती है बेटा? Plus minus 1.96. That's the value of z. So I will take z at 1.96. What is s given to me as? S is given to me as 21. So into 21. 21. What is n given to me as? Root 50 हो जाएगा. N is given to me as 50. Can we quickly do this calculation, please? So let me open the calculator. So it will be 21 into 1.96. Can you just tell me what this value will be? I'm getting this as 41.16. The root of 50 will give you 7.07, and this will be 871. So if I do 41.16 divided by 7.07, you will get 5.82 plus 871. So you will get this as 876.8. Right? And here you will have mu, and here you will have 871 minus 5.82. So you will get this as 865. Approximately something like this you will get. So you will get mu as, you will get the range between 865 to 876. Does this include 880? No, it is not including 880 na. So you will reject null in favor of alternative, because 880 is not included in this. How can we identify? Value given in the question is standard deviation of population. Beta, it will mention to you whether it is population or sample. That will be mentioned. In large sample, 99% of the time standard deviation, it will only be sample. Yes, most of the time sample is only given. But even if population ka diya hua hai, only the formula will say that this is sigma. The answer will be the same only. कोई एक ही दिया होगा, it will either be sample or population. Most of the time it will be sample. So this is how you can check using confidence interval approach. So you see that the confidence interval is between 865 to 876. And you see that 880 is not included. So you will reject null in favor of alternative. So either you can use this approach or you can use this approach. Both will give you the same answer. But sometimes in exam, they may ask you calculate the confidence interval, or which of the following is the right confidence interval, and 4 confidence interval will be given to you. So you should know how to go ahead and calculate this as well. Now, let's do the same analysis using the t-test. Now, when will I use a t-test? I will use a t-test if my sample size is less than 30. Now, here is where the trick is. Dhyan se sunna, huh? If my sample size is less than 30, then the formula to calculate sample variance. Let me represent this by S dash. So S dash square, it represents the sample variance when you have a small sample. Agar small sample hai, if n is less than 30, then the sample variance is given by summation xi minus x bar whole square divided by n minus 1. This is the formula for sample variance when the size of sample is less than 30. ये एकदम सही formula इसका होता है. But in question, whenever you are given the standard deviation, जब भी आपको ये standard deviation दी होगी sample की, they would have used this formula, summation xi minus x bar whole square by n. This is the formula used to give you the standard deviation given in the sample. अब ध्यान से देखो. If I have to go from this to this, तो मुझे क्या करना पड़ेगा? I must divide this by n minus 1 and must multiply this with n. Only then I will be able to go from this to this. This is exactly what I will be doing. So whenever we want to, because for small sample, the correct formula is this. But what is given to me in the question would be using this. So if I have to make relevant changes, I must go from this part to this part. There must be some way to do that. So that editing that I am going to do, this is what is required. Iska denominator n minus 1 hai. So I must somehow bring n minus 1 into it, and I must remove n from it. So this is what is written here. Let me just read it out for you. So try to see this. This is the correct sample variance. This sample variance is called an unbiased sample variance. And this sample variance is used for small samples. And we have proved in our classes why this is unbiased. When I did a lecture with you on unbiased sample variance, I did this complete proof with you that this is called an unbiased sample variance. But whenever you will be given a small sample, whenever n will be less than 30, the S that will be given to you in the question will be calculated using this. From this, you have to reach to S, which will be calculated using n minus 1. So in order to make certain changes in it, what we will be doing is, we will be bringing some changes around it. So let me just take one question and show that to you, how I will be making these changes. So this is how I will go back. Just see this for a while. This is how I will be making the change. So if we have to calculate the correct sample variance in small sample, we must multiply by n and divide by n minus 1. If I do this, only then I will be able to calculate the unbiased sample variance. And this is what I will be using to calculate my t value. T value के लिए मुझे मेरा unbiased sample variance चाहिए, और small samples के लिए unbiased sample variance denominator में n-1 रखता है, जबकि जो क्वेश्चन में दिया होता है that has divided it with n. तो मुझे n से वापस मल्टीप्लाई करना है, so that वो n वाला चीज रिमूव हो जाए. डिवाइड किया, मल्टीप्लाई किया, it is removed, and then I have to divide it with n minus 1. So I have to multiply in total it with n upon n minus 1. जो भी मेरे को क्वेश्चन में सैंपल वेरिएंस दिया होगा, it must be multiplied with n upon n minus 1. When I will do that, I will get the unbiased value of the sample. So what will be the steps now that I have to follow? एक बारी ध्यान से देखो. Whenever there is a t-test, step 1 and 2 are the same. That you will go ahead and you will have your null and alternative hypothesis created. This is the same. I will write my null, I will write my alternative. Step 2 is I will calculate the value of t in this case, not z, because n is less than 30. The value of t will be x bar minus mu upon sample standard deviation by root n, and this sample के जो calculate करना है, this will be calculated from what is given to me in the question by multiplying with n and dividing it by n minus 1. यहाँ से sample का मेरे को edited version of the variance मिलेगा. So when I will find out its under root, then I will get this way, this standard deviation, this value. That will give me the value of t. Now, next step. See, when you get the value of t, you must also compare it with the table value, जैसे हमने z में किया था. Now for t, there is something which is known as the degree of freedom. What is degree of freedom? थोड़ा सा इस पे एक बार डिस्कस कर लेते हैं. Try to see this. But suppose I tell you that choose any 5 numbers whose sum is 10. You can choose any 5 numbers. But I want that the sum of these 5 numbers should be 10. What will you tell me? You will tell me in that case that, okay, ma'am, my first number can be 1. My second number can be 4. My third number can be 1. My fourth number can be 1. You can choose any numbers. But the moment you choose these 4 numbers, then the 5th number will be dependent on what these 4 numbers have been. So 4, 5, 6, 7, this has to be 3 if the sum has to be 10. So how many numbers can you choose freely? You can only choose n-1 numbers freely. the fifth number cannot be chosen freely. It will be dependent. अगर मैंने first number 2 choose किया होता freely, then this number could only have been 2. So out of n numbers, I can only choose n minus 1 numbers freely. This is called my degrees of freedom. I have freedom only to choose n minus 1 numbers in a sample. Same is the case here. Whenever we talk about t, because it's a sample, then we have only n minus 1 degrees of freedom. Now, when you will go to this t table, you will be given some n in the question. Again, a t table will not be given. आपको direct value दी होगी, but I want to just explain you. So suppose you are given beta that n is, it has to be less than 30. Let's say n is given to you as 14. So what will be n minus 1? It will be 14 minus 1 equal to 13. So here are my degrees of freedom. So I will go to 13. Now I will be given some alpha. So alpha, let's say, is 5%. It tells you both the values. देखो यहाँ पे ये भी बताया हुआ है कि अगर वन टेल टेस्ट कर रहे हो तो क्या वैल्यू रहेगी और अगर टू टेल टेस्ट कर रहे हो तो क्या वैल्यू रहेगी. So alpha is 5% means 0.05. So if I have to do a two tail test, so under 0.05, I will go till here. So under 13 degrees of freedom, I will go here and my table value of t tabular will be 2.16. So for this you cannot remember because her degree of freedom के लिए answer अलग होगा. So this will be given to you in exam. It will tell you that t9, 0.05 is this. ऐसे करके values दी होंगी आपको. You don't have to use anything. But I'm just explaining you that for each degree of freedom, we will go to that particular alpha and get the value. हमें एक t की value मिलेगी. So I have gone ahead and I have calculated t. I have got t from the table. If my t calculated is greater than t from the table, then the analysis is the same. Reject null in favor of alternative. You will reject null in the favor of the alternative. Let's read another one of the questions from it. Then we can do it. So read here. 10 cohorts. The moment I read 10, it should strike in my mind, okay, I have to use a t-test. Z-test cannot be used. So my n is 10. Are chosen at random from an automatic filling machine. The mean net weight of 10 cartons is 11.8. X bar is given to me as 11.8. And the standard deviation is 0.15. So S is given to me as 0.15. Does the sample differ significantly from intended weight of 12 units? So my null hypothesis is that this is 12. My alternative hypothesis is that this is not equal to 12. So beta सबसे पहले क्या करेंगे? Because this is a t-test, I will have to edit this value. इस value को मेरे को edit करना पड़ेगा. So S dash squared up will be n S square upon n minus 1. So n is given to me as 10. N minus 1 will become 9. S square means 0.15 whole square. You will calculate this value. You will get the answer as 0. This. This is your S square. So then to find S dash, you will do its under root. You will use this S dash in your t value. So what will be t calculated? T will be x bar minus mu upon S dash by root n. Ye wala value is what I calculated here. This value, whatever I have calculated here. This is the value I will be using in this formula. Now, x bar is given to me at 11.8. So I will fill 11 point here. Mu is given to me at 12. So I will just put 12. This is what I have calculated from here. So this is what I have calculated from here. N is given to me at 10. So I will use root of 10. So when you will calculate this value, you will get t as minus 4. ये हो गया t calculated. Now t tabular means what? I have to go to the table. So what is my degrees of freedom? N minus 1. 10 minus 1, that means 9. What is given to me at alpha? So it is asking me to check this, say, at 5% level of significance. So I will check this at 5% level of significance. So I will just show you this from the table once. So I will go to 9. And I have to check at 5% level of significance under the two-tailed test. So my tabular value gives me 2.262. So this is what my table gives me. So from the table, I am getting T from the table is 2.26. T that I have calculated in absolute value is 4. So T calculated is more than T tabular. So I will reject null in favor of alternative. Baki sab same hai. All things are the same only in the way we did the Z test. The only thing that is differing here is how you're going to go ahead and calculate this value. ये जो एक addition है कि आपको n से multiply करके n-1 से divide करना है, this is the only additional thing that we are doing. Take another question. Suppose your company wants to improve sales. Yes, value will be given. Very, very less chance that they will be giving you a table, but what they will do is the following. मतलब वो क्या करेंगे ना बेटा, they will give you something like this to test your analysis. They will give you corresponding to 10 also. They will give you corresponding to 11 also. And they will give you corresponding to 8 also. So 9, 10, 8, 11 in सबकी दी होंगी. But you have to understand which is the value that you have to compare with. So for that, you have to remember that you have to check with the right degrees of freedom. So my degrees of freedom is 9. So only corresponding to 9, I will pick up the right value. I will not pick up the value related to anything else. In Z, you have to remember because Z की कोई गिनती की 3-4 values हैं. So a lot of times, like for example, Delhi University का जब paper आता था, they used to assume that a student would know these values. They never gave the values for Z test. T test होगा तो they will give you 3-4 values and you have to choose the appropriate. Okay. Suppose your company wants to improve sales, but the sales data indicates average sale was 100. After training Salesforce, recent sales data sample of 25. So again, beta, N is 25. 25 is less than 30. So T test. Indicate average sale of 130. So your mean is given to you as 130 with standard deviation of 15. So beta, again, let us make this change. So S dash will be N into S square upon N-1 under root. ये आपका updated standard deviation हो जाएगा. So N is given to you as 25 into your S is given to you as 15 upon your N-1 will become 24 under root. This will be your standard deviation that you have to use. Okay, then you have to check at 5% level of significance. So when you will write the hypothesis, it says that post sale, it says this is 100 and improve sales. Improve sales means it has to be a one-tailed test. So my null hypothesis
Ma'am,
will
how
be
to check the mu value? Means 100. Population mean, how to check population mean?
whatever statement will be given to you will be your mu value. So it says post sale data indicates average is 100. And यहाँ पर वो बोलेगा कि sample का after training Salesforce recent sales data from sample of 25 indicate average sale of 130. तो ये sample का value है. So this is your x bar. So this is your mu. So whatever will be given to you as a general statement without using the word sample, that will be taken as your mu. Okay. So then we say that initially it is mu, and then it is saying ki training ke baad there should be some improvement. So mu exceeds 100. That is my alternative that I want to prove. I want to use t-test. T will be x bar minus mu upon standard deviation by root n. ये स्टैंडर्ड डिविएशन को कैलकुलेट करने के लिए हमने जो भी हमारा s स्क्वायर आया होगा उसका अंडर रूट किया होगा. So this will be your standard deviation by root n. N is given to you as 25, so root of 25. X bar is 130 and mean of the population is 100. So when you will calculate this, you will get the answer as 9.75. So try to understand the components here. Sample जो होगा, sample की दो values given होंगी आपको always. One will be its mean, one will be its standard deviation. Population की आपको एक ही value दी होगी mean. What you have to test? If you have n greater than 30, तो आप इसको as it is use करोगे. And you will use z-test. When your n is less than 30, then you will use t-test. But if you are using t-test, then you will not use this as it is. तो जो भी आपको standard deviation दिया होगा, s दिया होगा, you will square that up. You will multiply it with n, divide it by n minus 1. और वहां से आप s dash square निकालोगे. You will find the updated sample standard deviation. The unbiased sample standard deviation for small samples. इसको आप फॉर्मूला में यूज करोगे. फॉर्मूला सेम ही है. z होता है तो it will be x bar minus mu upon s by root n. And small होगा तो it will be x bar minus mu upon s dash by root n. Everything is the same. क्या डिफरेंस है? यहां पे हम s को डायरेक्टली यूज कर रहे हैं, व्हाट इज गिवन टू अस. यहां पे हम s को अपडेट करके यूज कर रहे हैं. ये हमारी कैलकुलेटेड वैल्यूज हैं. These calculated values will be compared with tabular values. When it is z, तो इसकी tabular values should be known to us. 1.96 at 5%. 1.645 at 10%, 2.56 at 1%, under one tail. ऐसे ही आपको under two tail, ऐसे ही आपको one tail की याद होनी चाहिए. You have to compare it with the table values. Table values you should remember. If it is a small sample test, तो आपको t-test की tabular values will be given. You have to compare it with the tabular values. If your calculated value is greater than the tabular value, you will reject null in favor of alternative. Steps are the same. सब कुछ same है. Formula भी same है. The only thing that differs is here you have S, here you have S bar. That's the only difference. Tabular को compare करना है calculated से, that's also the same. What differs? जो table की values होंगी. Tabular values of Z is different and tabular values of the T is different. Tabular value of T will depend on the degrees of freedom. So that's the only thing that differs. Otherwise, everything is the same. So when you will see in the table, the value is 1.711. What you calculated is 9.7. So the calculated is greater than tabular. So you will reject null in favor of alternative. That's the only difference that you have. Yes, tell me.
Excuse me, ma'am. Ma'am, the changes we are making it when it's a standard deviation. Otherwise, अगर variance already given is, so we do not make it because it is an unbiased estimator. Already we know कि वो unbiased estimator of population का variance है, right?
You still have to make the changes. Variance just means that this is given to you. Summation xi minus x bar whole square by n. This will be given to you in the question. This is what I am saying. But you have to use this. So this is unbiased. You have to reach this. This is given to you in the question. So it does not matter. If it is standard deviation, मतलब इसका under root दिया हुआ है. But you still have to reach from this to this. So you have to make the changes.
So ma'am, variance भी दिया हुआ है, then also we have to make the changes, right?
Yes. Yes.
Okay.
You always have to make these changes. What is given to you in the question is calculated on the basis of n. Because just think about it, na? See, leave everything. If I today give you this, कि बेटा x की ये values है 10, 15, 20, 25, 30. And I ask you, बेटा calculate variance. कैसे calculate करोगे? You will simply do this, na? Summation x bar, my x minus x bar whole square by n. This is what you will do to calculate the variance. If I don't tell you कि ये एक sample है जो population से आता है, how will you calculate the variance? Like this? In our case, because now I know that it is a sample, I have to make the relevant changes. So now to make those changes, because it is a small sample, I am going ahead and making these changes. Otherwise, generally, you will always divide by n. So these changes are updated now in this context that this is a sample, which is a small sample, which is used in hypothesis testing. Therefore, we now make these changes.
And ma'am, one more thing, like if the t test is not given, like t table is not given, so we write t 0.05 comma 9. So it would be mentioned that 0.05 is a one tail or either it's a two tail, right? It will be mentioned in the question if they have given directly the value.
It will be mentioned. So ideally what will happen is they will either tell you both one tail, two tail, or if they just give you one, that means that they have given for the right tail. If the question is asking you to test one tail, and they have just given you this, मतलब उन्होंने one tail से related ही value दी होगी. They haven't taken it from two tail.
Okay, ma'am.
Most probably 99% of the time till now, whenever question has been asked, a table has never been given. But that is why I've just shown you how the table looks. They usually will give you the value already in the question before you can attempt it. For Z, they will not give you. And for Z, you should also remember these values. Okay. So again, beta, this is based on exactly the same analysis. I want you to do this question. This is an important, same way you can do this question. So read it out. It says that a mean weekly sale of candy bar in candy store was this. इसमें sample की बात नहीं हो रही है. ये mean weekly sales है. मतलब ये mu है. This is mu. Now it says that you have n as 22. So n is less than 30. So it is t-tail. For a typical week, increases to 153.7. ये sample की बात कर रहा है. So this is your x bar. And showed a standard deviation of 17.2. So S is given to you as 17.2. You have to use t-test. Same. T-test का formula will be x bar minus mu upon S dash by root n. S dash के लिए you have to make these appropriate changes. So multiply with n, divide by n minus 1. You have got your S dash. Root n, you know. Mean, you know. इसका ये value दिया हुआ है. You calculate it. This tabular value will be given to you. इसका value calculate करके 1.9716 आएगा. T calculated will be more than T tabular. So you can reject null in favor of alternative. So I hope the process is clear. The process is exactly the same. But the only thing that differs is this analysis that you have to do. If it is t-test, you will do S dash. If it is z-test, the z-test, you will use S. Otherwise, everything is the same. Confidence interval निकालना भी same है. if I have to calculate the confidence interval in this case, beta, then it will be this, that mu is between x bar minus t plus t into s dash by root n, into s dash by root n. Everything is the same. अब s dash use होगा यहाँ पर confidence interval में. So the value of s I will be using, s dash I will be using will be this. And here the value of t will be used. So t is always t from the table. So that value which will be used will be 1.721. So if I were to calculate this, if I were to calculate the confidence interval, it will simply be that x bar is given to me as 153.7, 153.7. T will be given to you and T is given to me as 1.721, 1.721, and s dash by root n is this value, root 309 by root 22, root 309 by root 22. This will be its confidence interval, just the way I did in Z. इसमें और Z में कोई difference नहीं है. What are the changes? One, instead of Z tabular, यहाँ पे T tabular use हो रहा है. And second, instead of S, यहाँ पर S dash use हो रहा है. These are the only two changes that you have. Okay. So I'll stop here for today. I will give you some questions based on this also. And I will post some related to type 1, type 2 error also today that I did in yesterday's class. And just practice them before we do the next class. Hi, good afternoon, everyone. In today's class, we are going to go ahead and look at some of the tests related to the difference in the population mean. So let me start with the first one. Just try to understand. What this is coming from the notes of the last class. I wasn't able to complete these notes completely, so I am just continuing with those notes. So now just try to understand that. Let's say you have a sample that you are collecting from, two samples that you are collecting from a population, right? And you want to test if those samples have the same properties or not. Is there any difference between the mean of the sample or they represent the same mean? That is where we want to go ahead and we want to test for the significance of the population mean. Before we go into the formula of it, let me just read out a question for you. Then I will go into the formula. So let's read this out. An investigation of the relative merits of two kind of flashlight batteries shows that, so two batteries are there now, not one battery, huh? It showed that a random sample of 100 batteries of brand A lasted on average for 36.5 hours, and then the standard deviation is also given to you. So एक sample हो गया battery A's का. While a random sample of 80 batteries of sample B, this is second sample, this is of battery B. Uska alag se they have given that this is the average and this is the standard deviation. Test that whether the average life of battery is the same or the not. So what are we doing in this case? I have two separate samples now. They have their own means. We want to test if their average mean, average life of battery A and average life of battery B, is it the same or not? That is what I want to test. क्या ये same है या नहीं है, वो हमें test करना है. Now, whenever you want to go ahead and do such things, that is called as test of significance for population mean. Just like we did for single mean, beta. तो single mean में क्या था? That if my n was greater than equal to 30, I was using Z test. And when my n was less than 30, I was using T test. Same is the case with difference in means also. So in case of your difference in means also, you will use Z test when the sample size is big enough and you will use t-test when the sample size is not big enough. Now, again, we can have two kinds of hypotheses. One can be a two-tailed hypothesis and one can be a one-tailed hypothesis. When I talk about a two-tailed hypothesis, then I am just trying to say that there is difference between the two means. मतलब अगर मेरे को सिर्फ ये बोलना है कि हाँ, बैटरी ब्रांड ए की जो बैटरीज हैं और ब्रांड बी की जो बैटरीज हैं, उनकी एवरेज लाइफ अलग है. They have different average life. Then I am using a two-tailed hypothesis. But if I have to make some comment that no, brand B has more average life than brand A, or brand B has less average life than brand A, when I will do this kind of comparison, that you know what, I want to prove that brand B's average life is more than brand A's average life. So which means mu B minus mu A is greater than 0. So when I will be involved with the signs, then it will become a one-tail test. So here, for example, it just says they are different. That means I just want to prove that mu B and mu A are not the same. The two average life are different from each other. So I just want to prove that mu B minus mu A is not equal to 0. So ye ho gaya. But if it would have said that check that the average life of brand B is more than that of brand A, it would have been a one-tail test. So this is exactly what I have gone ahead and written here, that it can be, but this is all what we did in the last class also, just that now I have it with respect to two sides. So this is just saying that this is not equal to 0. They are different from each other. And this is just saying that this can be greater than D or less than D. Now, why have I written D here? Why not 0? Because sometimes they may say that, okay, check that the difference between average life of battery is not 2. So I have to check that the difference between the average life of battery is not equal to 2 or is equal to 2. So this may not always be 0. Sometimes you have to check that unka jo difference hai, it is not equal to a certain number. So therefore I have written D here. D represents the difference between the two mean. This says that in dono ke beech ka difference exactly D ke barabar hai. And this says no, the difference between the two is not equal to D. So when you have this not equal to sign, it becomes a two-tailed test. When you have these signs, it becomes a one-tailed test. Now let's talk about the value of Z. How will I calculate Z? So this is the difference between the sample means. This is the difference between sample means. This is the D value which will be given to you based on population or based on the hypothesis you want to check. जैसे यहाँ पे मेरे को चेक करना है कि इन दोनों का मीन बराबर नहीं है. So I want to check that mu B is not equal to mu A. So I want to check that mu B minus mu A is not equal to 0. So what will be my null? My null will be mu B minus mu A is equal to 0. And my alternative will be mu B minus mu A not equal to 0. So whatever will be your null value, that is what you assume in the population. So ये जो D है, this D represents that null value that you have taken. That represents the null hypothesis value that you have taken or the population value that you have taken. Divided by, this is your standard error. So standard error, because now I have, so usually हम क्या लिखते थे Z का value? What were we writing Z as? X bar minus mu upon standard deviation by root n. And when sigma was unknown, तो हम sample का ले रहे थे. We were writing X bar minus mu upon S by root n. So beta, S by root n is nothing but S square by n under root. अगर मैं इसका under root निकालूंगी, then I will get S by root n. But now I have two samples, ना? So therefore, क्योंकि ये अब एक sample का नहीं रह गया, there are two samples involved. This is written as S1 square by N1. So now I have two samples. So this is my sample 1. Similarly, this is from sample 2, right? And then under root. So instead of just this, जो हम पहले लिखते थे S by root n, because I had a single sample, now I am just writing S1 squared by n plus S2 squared by n2 under root. So I'm just writing it for 2 samples. Okay, now let me read this question again. So an investigation of relative merits of the 2 kinds of flashlight batteries showed a random sample of 100 batteries. तो मैंने पहले n लिख दिया बेटा यहाँ पे, sample 1 का 100, and then it says 36.5 is the average. Correct, you're right beta, it is still called the standard error. So this is 36.5 and the S is given to you as 1.8. And for sample B, it is given as 80, 36.8 and 1.5. Now my null hypothesis is that mu1 minus mu2 is equal to 0 because it is saying that there is no difference between the battery lives. तो null बोलता है कि जो पहले की average battery life है और दूसरे की है, they are equal. So mu1 minus mu2 is equal to 0. This is what null is saying. An alternative is saying that mu1 minus mu2 is not equal to 0. Now I will use my formula. So my Z formula I had was x1 bar minus x2 bar minus d upon s1 square by n1 plus s2 square by n2 under root. Beta d is 0 from here. This is what null is assuming. There is no difference. x1 bar is given to you here. So you will put 36.5. x2 bar is given to you here. So you will put 38.5 minus 0. S1 is given to you as 1.8. So you will put 1.8 whole square by 100. S2 is given to you as 1.5. So you will put 1.5 whole square by 80 under root. So when you will solve this, you will get the answer as minus 1.2195. Now, बाकी सब same है. This is my Z calculated. I will have to go to Z table. So we know that for 95% level, this is 5% level of significance. So 95% confidence level, we know that the Z value in two-tail is 1.96. यही हमने देखा था. Z value is 1.96 in two-tail and it is 2.5 when it is 99% and it is 1.645 when it is 90%. ये तीन values we had to remember. So this is exactly what I am doing, that okay, my Z calculated in my absolute value is 1.2195 and my Z from table is 1.96. So we can just plot this. This is 1.96. After 1.96 and before minus 1.96, this is my rejection region. My value, this बीच में होता है 0, right? My value is 1.2195. So my value is here, 1.2195. It is lying in non-rejection region. This is my rejection region. This is my rejection region. So it is lying in the non-rejection region, na? So I will not be able to reject the null. This is the same. जो हमने last classes में पढ़ा है, exactly the same. I am not doing anything new in this. It is just that now I am introducing it for two sample tests. That is it, that we have done the change. So I am not able to reject the null. So we can say that there is no difference between the battery life of brand A and brand B. Let's take one more question. It says if 60 BTech computer science students have found to have height of 63.60, 60. So I have taken, you can again make this. So N1 is 60 and N2 is 50. And इनका mean आया है 63.60 and BTech mechanical students have found out to be the mean of 69.51. Would you conclude mechanical students are taller than the computer science student. तो अगर ये mechanical students का mean है और ये computer science का, so would you say that mu2 is greater than mu1 or mu2 minus mu1 is greater than 0 or mu1 minus mu2 is less than 0? ये तीनों ही तरीके, they are correct to write the alternative hypothesis. I have written the same thing. So I am just saying that the mechanical engineering students have more height than the computer science students. This is my alternative hypothesis. So null will be the reverse of it. So you can just say null will be this. Or equal to is also fine. In many books, you will just see the equal to sign. Then beta, you will just go ahead and you will use z. So what is the formula of z that we have found out? x1 bar minus x2 bar minus d upon s1 square by n1 plus s2 square by n2 under root. Now look at this question. This question says assume standard deviation of all undergraduate student is 2.48. So basically in this case, we are given sigma itself. But when were we using S? We were using S when sigma was unknown. So actually, जब मेरा Z का formula था, it was x bar minus mu upon sigma by root n. When sigma was unknown, population का नहीं पता था कि पूरी population का as a whole कितना है, then I was using z is equal to x bar minus mu upon s by root n. This is what I was doing. Now, if you go ahead and you compare it with the two sample tests, it's the same thing. If you go ahead and you tell me कि पूरी population का sigma कितना है, I will simply use sigma 1 square plus n1 sigma square by n2 under root, because I already know what sigma is, na? And sigma is the same. It is coming from one population. In this case, the undergraduate students. But when I don't know sigma, that is when I will use the sample. That is when I will use s1 square by n1, s2 square by n2 under root, just like this I did. So here in this case, they have given me sigma itself. They have given me that this is 2.48. So I can just use that sigma as it is. So if I just, because this is common, if I just take this out upon d, if I just take sigma square common, I will get this. And then sigma square can come out of the under root. It will become sigma. So it will be x1 bar minus x2 bar minus d upon sigma. In under root, I will have 1 by n1 plus 1 by n2. This is the formula that I have used here. Because it is telling me that, look, all have the same sigma, which is 2.48. And this is true for all undergraduate students. So I have just used sigma value as it is, as this 2.48 given to me. So now what will be your analysis? How will you go ahead and do this? So you can just go ahead and you can just put this 63.60 minus 69.51, x1 bar minus x2 bar, d is 0 upon sigma is given to you as 2.48 under root 1 by 60 plus 1 by 50. This is what you will have. So when you will calculate this value, you will get this as 12.48. This is your Z calculated. Again, beta, this is given to me at what? If nothing is mentioned, I will assume at 5%. So the 5% value of Z is 1.96. So I can just go ahead. Sorry, it is 1.645. This is one tail test. So 5% will be 1.645. Now I can just compare. So my Z tabular is going to be greater than Z calculated. Sorry, Z calculated is going to be greater than Z tabular. So I will be able to reject my null. I can make that and also see. So now I am saying that this is my 1.645. This is my rejected region. And what I have calculated has come out to be 12.44. So what I have calculated has come out to be 12.44. So it is clearly in my rejection region. So I will reject null in favor of alternative. And I will say that in fact it is true that mechanical engineering students have an average height more than the computer science student. Now this is a question which is based on confidence interval. Let's read it out. It says construct 95% confidence interval for difference in average academic achievement between car owner and non-car owner. So just think about it. See, this is my usual formula that I have. That Z is equal to x1 bar minus x2 bar minus D upon S1 square by N1 plus S2 square by N2 under root. But I can call this entire term as the standard error. So I will just remove this and I will call this as standard error. Right? I can take this standard error here. And I know that sometimes that, this is symmetric. Z has, it's a normal distribution. So Z has positive values and negative also. This is plus minus. So I can just have plus minus Z into standard error is equal to x1 bar minus x2 bar minus D. But D kya tha? D was representing the difference in the population mean. Yahi to D tha, difference in the population mean. So if I want to find the value of D from here, how can I find D? What will be D? D will be, I can just take D here and this thing here, x1 bar minus x2 bar plus minus Z into SE. D was what? The difference in the population mean. So the population mean the difference in the population mean can go ahead and it can lie between x1 bar minus x2 bar minus Z into standard error and x1 bar minus x2 bar plus Z into standard error. This is going to be my confidence interval. Now let me just find this out. So this tells me that I need to find this confidence interval at 95%. So we know that if it is 95%, the value of Z will be 1.96. So Z ka value will be 1.96. So I can just go ahead and instead of Z, I can plug this value of 1.96 and 1.96. Now I need to find out what my standard error will be. So I am given that S1, this variance is given to me as 0.36 and this is given to me as 0.40 variance. So variance matlab ye wala value diya hua hai. Ye wala value. Variance is already given to me. Right? S1 was standard deviation. S1 square is variance. So I am given this as 0.36 divided by the sample size N1 is given to you as 100. Please write this down here. I haven't written it here. The sample size is 100. So it will be 0.36 divided by 100 plus 0.40 divided by 100 under root. So I can just say that this is going to be 0.36 plus 0.40 divided by 100 under root. So 0.76 under root divided by 10. This is going to be your standard error. Okay, let me explain it again. So this is going to be your standard error. So now you have found out the standard error also. You know the value of Z also. And x1 bar minus x2 bar is simply going to be 2.70 minus 2.54. So this is what I have plugged in here. 2.70 minus 2.54 plus minus. The variance is given to you as 0.36 divided by N1. Other variance is 0.40 divided by N2 under root. So when you will calculate this, you will get 0.16 from here plus minus 0.17. So this gives me that the confidence interval is between minus 0.01 to 0.33. Now, if my null hypothesis is that there is no difference between the population mean. Is 0 included in this? Yes. So will I be able to reject my null? No. So we cannot reject null in favor of alternative. Null cannot be rejected. Yes, we will multiply this is multiplied, you're right, beta. This is multiplied with 1.96. Only then you will get this value. 1.96 needs to be multiplied, correct. Okay, so let me just explain this once again for anyone who has a doubt in this. See that beta, my Z value is calculated as x1 bar minus x2 bar minus difference in the population mean. ये hypothesis की जो value है, divided by S1 square by N1 plus S2 square by N2 under root. The Z value is both positive and negative. It is a symmetric table. ये ऐसे बनता है. It's a normal distribution. So you have here also, this is Z alpha by 2, 1.96 होता है for 5%. And ये Z alpha by 2 यहाँ पे minus 1.96 होता है. So this is symmetric, plus and minus. So what we are doing, we are using both plus and minus here. This entire value is called as standard error, जो भी denominator में आता है. So I am just writing that plus minus Z is equal to x1 bar minus x2 bar minus D upon standard error. I am taking standard error here. So I am saying plus minus Z into standard error is equal to x1 bar minus x2 bar minus D. So if I were to calculate D can go here and this can go here. So D will become x1 bar minus x2 bar plus minus Z into standard error. So जो मेरी D की वैल्यू है, D क्या था? D was the difference in the population mean. जो हम hypothesis testing का null hypothesis लिख रहे थे, that will be between x1 bar minus x2 bar minus Z into standard error. x1 bar minus x2 bar plus Z into standard. So one time I am adding it and one time I am subtracting it. This will be my confidence interval. Now you can just calculate this value. So standard error को आप अलग से calculate कर सकते हो. This is variance of sample 1 divided by n1, variance of sample 2 divided by n2 under root. Right? Z का value is based on alpha. So if your alpha is 5%, Z will be 1.96. And this will be given to you in the question. What is x1 bar and x2 bar? So based on this, you can find the confidence interval of mu1 and mu2. Is it? Just let me just quickly calculate it. Huh? So it will be 0.76 under root. That will be 0.8717 divided by 10 into 1.96 plus minus, and this is 0.16. So if I just go ahead and do this divided by 10, this entire thing is giving me 0.17086 plus minus 0.16. This is what I am getting using calculator. This is what it is written. I just missed writing this here. But this is exactly what I'm getting. I hope all of you are getting this. So mu1 minus mu2. Okay. So mu1 minus mu2. Because 0 is included in this interval. So if 0 is included in this interval, it means I have the null value included. So you cannot reject null because the null value is included in the confidence interval. So we can say that we cannot reject null in favor of alternate. सब कुछ सेम है जो हम सिंगल मीन में करते थे, just that now we are doing it for double mean, 2 sample test. Okay, now if I go ahead and I want to do this same 2 sample test, but I now have smaller sample size. Let me first show you a question based on it. Then we will come back to this concept. So read this out. Sab kuch same hai. It says a random sample of 20 daily worker of state A found to have average earning of 44 with sample variance 900. Another sample of 20 daily workers from state B was found to earn on an average 28 per day with sample variance 400. Test whether worker in state A are earning more than worker in state B. Sab kuch same hai, like we did in the above cases. So I want to check whether worker in B are earning more than worker in state A. This is what we want to check. And it says more than 2. So which means I want to check whether mu B minus mu A is greater than 2. I suppose. So this is the same only, the same thing that we have done till now, that I will create my null hypothesis that mu A minus mu B is equal to some D. My alternative can be mu A minus mu B not equal to D, or mu A minus mu B greater than D. This is the same what we did. The only thing that has changed now is that my sample size is small. वहां पे sample size जो अभी हमने example लिया उसमें 180, that was the sample size. But here my sample size, my n is less than 30. So when, if you remember, if I go back to my t-test for one sample, which we did in the class last time, when it was a one sample with n less than 30, we were going ahead and using t-test. And the t-test had the concept of degrees of freedom that we were using. Hai na? So now also things are the same. I will, because my n is less than 30, I will be using t-test. And in this t-test, I will be using the concept of degrees of freedom. So I will just compare this with Z ones. Huh, beta? Let me just go ahead and take this one time here. So let's go ahead and say that my Z is x1, x bar minus y bar minus D upon S1 square by N1 plus S2 square by N2 under root. ये मेरा Z था. Now, if you compare it with T, it's just that instead of S1 square and S2 square, I have written a pooled S, a common S. But the question is, how do I find out this common S? How do I find out this pooled variance? So, if you remember, जब हम t test कर रहे थे, we were finding summation xi minus x bar whole square by n minus 1. And we were saying कि for small sample, this is an unbiased estimate of the variance. Same is the case here. When you have to find this S, for finding this S, you have to use the concept of what is known as a pooled variance. This pooled variance is basically going to be taking into consideration the first part, the first sample, the second sample squared deviations divided by n1 plus n2 minus 2. Because now I have to consider degrees of freedom of both. तो अगर आप ध्यान से थोड़ा सा देखो, earlier I was finding summation xi minus x bar whole square upon its degrees of freedom. So अगर एक और sample होगा तो उसका yi minus y bar whole square upon its degrees of freedom हो जाएगा n2 minus 1. ये हो जाएगा n1 minus 1. Now I am going ahead and finding their pooled variance. So in order to find the pooled variance, the formula is this. But many times you will not be given summation exercise. उसकी जगह पे आपको क्या दिया होगा ना? You will be given sample 1 का variance and you will be given sample 2 का variance. So you will be given the variance of the individual samples and you will have to find the pooled variance. So in order to go ahead and find this pooled variance in that case, what we can go ahead and do is, we can go ahead and, let me take some space here. We can assume that for single sample, so sample 1 may, you would have calculated its variance using summation xi minus x bar whole square by n. And sample 2 may, you would have calculated its variance using summation yi minus y bar whole square by n2. So from here, if I am to find summation xi minus x bar whole square, I can find this out as summation xi minus x bar whole square is equal to s1 square into n1. And यहाँ पे निकालने के लिए I can assume this as yi minus y bar whole square will be s2 square into n2. So then I can just replace that my xi, ये जो value आया है, this xi bar, I have got this as this part as n1 into s1 square. And I have got this part as n2 into s2 square divided by n1 plus n2 minus 2. And this will be the final formula of my pooled variance. Now someone is asking why we use pooled variance. Because we want to find an unbiased estimator of the population variance. Population तो मुझे पता नहीं है population का variance. तो उसका unbiased estimator निकालने के लिए मुझे एक sample का pooled variance निकालना पड़ेगा, which can be used instead of the population variance. Why can't I use individual variances? Because now this is a small sample. And small sample are not normally distributed on their own. So we need to find unbiased estimators of these samples so that I can use them instead of the population variance, just like the single sample t-test. So now, let me just take you through a question. A random sample of 20 daily workers, so my N1 is given to me as 20, was found to have a daily average earning of 44. So I've taken this as 44. And S1 square is 900. That means the variance of the first sample. ये दिया हुआ है मुझे. Sample का variance. ये दिया हुआ है. S1 square is given to me. Then it says that another sample of 20 daily workers is having its mean as 28 and variance is given to me as 400. Test whether worker in state A are earning more than 2 than worker in state B. So I have to check whether worker in state A minus B, is this gap more than 2 or not? ये मेरा alternative हो गया. So null will be mu1 minus mu2 less than equal to 2. So first of all, the first thing I will do will be finding my pooled variance. In many times in exam, they will not even ask you anything related to hypothesis. They will simply go ahead and ask you find pooled variance. Bas, utna hi question hoga. So you just have to use this formula to find the pooled variance. So what will be my pooled variance? My pooled variance will be N1 into S1 square plus N2 into S2 square upon N1 plus N2 minus 2. When will I use this concept of pooled variance? When I see that N1 is less than 30, N2 is less than 30, I will be using the concept of pooled variance. This is what we will do in this case. Now, just go ahead and put these values. So this will be 1800 plus 18,000 plus 8,000 divided by 38. And you will get the answer as 648.21. Now we will put it in the t value. So my t value is x1 bar minus x2 bar minus the difference upon. अब s1 square, s2 square अलग-अलग तो है नहीं. I just have one pooled variance. So I will just have s coming out. And then this will be under root of 1 by n1 plus 1 by. ये मेरा pooled variance है बेटा. This is my pooled variance, s square. So my s will be under root of this pooled variance. So instead of s, I will be putting this under root of pooled variance. And then my mean of the two sample is given to me as 44 and 28. So I've just plugged this 44 and 28. And the difference D is given to me as 2. Pick D always from the null hypothesis. So D is given to me as 2. Root of 648.21. 1 by 20 plus 1 by 20 under root. So when you will solve this, you will get the answer as 1.7389. So we can understand that my t calculated is 1.7389. Now, remember, beta, this is t. So t के लिए we had a table. और table में हम उसको उसके degrees of freedom से compare कर रहे थे. So now in this case, the degrees of freedom will be, so when it was a one sample test, the degrees of freedom was n minus 1. Now there are two samples. So n1 minus 1 plus n2 minus 1. दोनों का degrees of freedom add हो जाएगा. So it will be n1 plus n2 minus 2. So in this case, my degrees of freedom will be sample size is 20 plus 20, 40 minus 2. So this will give me 38. If I just quickly, I think I had in this page. If I just go back to last time's note, and I will just show you once. So this was like this now. If you remember, this is my degrees of freedom table that I had. And if you just go here, so my degrees of freedom is 38. So यहाँ पे 38 नहीं दिया हुआ. Either 30 or 40 is given. It's a large thing now. So I can just take 40 from here. And against 40, I have to check at 5%. And it was a one-tail test. So I will go to one-tail test and I will check it at 5%. So I will just take this value and this value. And I will get this. Approximately 1.68, right? So this is how I can go ahead and I can find the value of one-tail test under your 38 degrees of freedom. But again, you will be given this. So this is suppose given to me. I've just taken it from the given data set. क्योंकि exact 38 के लिए computerized book दे देते हैं कि 38 में क्या होगा. Table में 30 या 40 given है. That is why we were getting 1.68 for 40. So we can see that now my calculated value, this is clearly more than my tabular value. So you can see that my calculated value is here 1.73. My table is 1.64. This is my area of rejection. So I will reject null in favor of alternative. Ideally, those values will be given to you. But if you notice, it will not make much difference. Between 30 to 40, the value doesn't change really much. So this is just 1.9, 1.69 and 1.68. So even if you take average, it will not matter. You see, till 2 decimals, things are so same, right? So ideally, it does not matter. Moreover, you will be given these values. It is very less likely that they will be circulating a table unless they go ahead and give you a computerized table. So you will be given these values most of the time. But average लेने का जरूरत नहीं पड़ेगा. So you understand this, whether this is 1.68 or 1.69, they are so close that it will still be rejected.
Excuse me, ma'am.
Yes.
Ma'am, when t-test we were using for the single mu, then we were using the S bar, no? That is for the unbiased estimator, that S bar is equals to under root n into S square divided by n minus 1.
Correct.
So can't we use it in this way also, like for this question?
I'm using a very similar thing here. I have already taken into consideration the degrees of freedom in the denominator. So instead of n minus 1, I have n1 plus n2 minus 2. And here I am just converting it. So instead of summation this, so individual samples were using this formula. I've taken that also into consideration. So in a way, it is a very similar thing. Right?
Okay.
So you're using both those concepts here. Okay, now let's take the next question. So this is the average number of articles produced by 2 machines per day is 200 and 250. So you are given that this is 200 and this is 250 with standard deviation 20 and 25. So you are given that the standard deviation is 20 and 25 on the basis of record of 25 days production. So your N is given to you as 25. Can you regard this machine equally efficient at 1% level? So it is asking, is the machine equally efficient in the 2 samples? Equally efficient means there should be no difference between the average. No difference between the average means mu1 minus mu2 should be equal to 0. So your null will be that mu1 minus mu2 is 0. And your alternative will be that mu1 minus mu2 is not equal to 0. So now you have to find the, so you can see, right, that n1 and n2 are less than 30. So since they are less than 30, you have to go ahead and you have to find the pooled variance. So you are using the formula of pooled variance. So you will get n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. So n1 हो गया 25, s1 square हो गया 20 square, n2 is 25, s2 square will be 25 square, and 25 plus 25 is 50, minus 2 is 48, so denominator is 48. So your pooled variance that you will be getting will be 533.85. So pooled standard deviation will be under root of 533.85. Now you can just use the T formula. So T formula is x1 minus x2 bar minus the difference upon S under root 1 by n1 plus 1 by n2. Difference is coming from the null hypothesis, which is 0. So D is just 0 here. The difference between the mean is 200 minus 250. So you can write 200 minus 250 here. S is given to you, has been found out as 533.85 under root into your n1 and n2 are 25 each. So 1 by 25 plus 1 by 25 under root. Right. So when you will solve this, you will get the answer as minus 7.65. This is your T calculated. T from table. Again, beta, you can go ahead and you can go to the table at 1%. You will get the value as 2.5. Achha, one thing I want to highlight here. See, although individual N1 and N2 are less than 30, but N1 plus N2 is greater than 30. यहाँ पे ये 25 था, यहाँ पे ये 25 था, पर मिलाके तो 50 हो गया ना. When N1 plus N2 is greater than 30, it means ideally just N पे, just degrees of freedom पे I am checking that is greater than 30. But isn't greater than 30 a Z test only? It's a large sample size, right? This is what we used to do in one sample. So therefore, a lot of times, if in exam, you are not given the value of T at that degree of freedom, but N1 plus N2 is exceeding 30, you can use the values of Z. This is what can be done here also. So we know that at 1%, the value, क्योंकि sample अब n1 plus n2 minus 2 48 है, it is much more than 30. तो z का 1% पे value होता है 2.58. So I can simply use that without going to the table, without anybody telling me the value. Same here. Just compare here. But a 1.645 is the value at one tail test of z only. 5% में z की value 1.645 ही होती है. So because this totally has exceeded 30, it means I can use the values of z table. और z की मुझे one tail test की value पता है, that at 5% one tail test gives me 1.645. So I can simply plug this 1.645 even when you don't tell me the values from the table, right? So this is what we can be done here. You can simply compare it with 2.58, and since the calculated is more than the table value, you will reject null in favor of alternative. Now, another alteration in this kind is the following. Just try to understand, huh? This is called as paired t-test. Yes, you're right. Correct stated. Okay. Now I want to talk about paired t-test. What is this paired t-test doing? This paired t-test, it says, look, now I am talking about the same sample. देखो एग्जैक्ट समझने की कोशिश करो. जो हमने आज फर्स्ट एग्जाम्पल लिया इन z test, n was, my sample sizes were greater than 30, but I was using two separate sample की, ठीक है, स्टेट A की wages ले लो, स्टेट B की wages ले लो, and इनको कंपेयर कर लो, या बैटरी लाइफ ऑफ A ले लो, बैटरी लाइफ ऑफ B ले लो और इसको कंपेयर कर लो. Then I used z test. I used t-test when my sample size became less than 30. And then I said कि ठीक है, okay, I am doing exactly same thing कि दोनों का wages compare कर लो, दोनों का battery life compare कर लो, just that my sample size is smaller. Now I am using paired t-test. And what paired t-test is doing, pick on one sample, एक ही sample है. But this sample is tested before and after some things are done to the sample. और वो क्या हो रहा है? जैसे for example, I may say that I have 10 students marks. And then what I do is, I will put them to some coaching institute. And after that, I will again record the marks of the same 10 students. And I'm asking, have their marks improved? So in a way, they are the same people. But I have two separate samples of these people. Now, one is before they were taking coaching, one is after they were taking coaching. Same. I have some people who have diabetes. Now I go ahead and I put them to some depression relieving exercises. And then I test their diabetes again. And I ask, has their diabetes improved? So it's the same sample now. But now what I am doing, it is before experiment, after experiment, seeing if the experiment has worked or not. This kind of activity is called the pooled t-test. This is where, paired t-test. This is where you will use paired test. So you will have the same sample size because you will be talking about the same sample. Let's take a question on this. So this is saying that you have an IQ test that was conducted for 5 people before and after they were trained. So this is IQ before their training was done. This is their marks or IQ test marks. And after their training was done, this is their IQ test marks that were given to me. Now, I need to ask myself, is there any difference that has been created in their IQ marks? Has their IQ improved or not? So let mu1, let this represent the average IQ marks before training. And let mu2, it represent the average IQ marks after training. So now what I'm going ahead and doing is I am finding the difference between the two. So my null hypothesis is that before and after training, their IQ marks are the same. and my alternative is nana. They have changed. So they are not equal to each other. So now, in this case, देखो यहाँ पे देखो, this implies my mu1 minus mu2 is equal to 0. And this implies my mu1 minus mu2 is not equal to 0. So if I were to find the t-test, usually जब हम t-test करते हैं, how do I do the t-test? x1 bar minus x2 bar minus difference upon s under root 1 by n1 plus 1 by n2. ये मेरा formula था, the formula that I studied above. But now, because I am talking about the same SAM, what I can do is I don't need this 2 sample test anymore. एक ही kind of people and they are the same sample. I don't have N1, I don't have N2 anymore. I just have one sample I am talking about. So in this case, what I will do is I will not be using this formula of 2 sample test. Rather, I will be saying this formula where x1 bar minus your value of the population upon standard deviation by root n. इसको मैं एक ही sample मानूंगी. So this formula will be used. But the question here is what will be the mean? क्या हम mean पहले sample का लेंगे? Should I take the mean of this sample or should I take the mean of this sample? So this is where my formula will change a bit. I will be taking the average of the difference in the means. Because I'm asking myself, how does this difference change? So जो मेरा new variable एक create होगा, that new variable will be the difference in the IQ. I will be finding the mean of that. I will be finding the variance of that, of difference in IQ, and then I will be putting a t-test. So let me show you how we will do it. So these are my x values. X represents before training is given. These are my y values. Y represents after training is given. Now I will create another variable which is called the difference variable. So this difference variable will be called as D. And this will be x minus y, x minus y, x minus y, x minus y, x minus y. So when you will do this, you will get minus 10, 2, minus 2, 4, minus 4 and 4. You will have, ये नया variable create हो गया D. You will have to find the mean and the variance of this variable D. So what will be the mean of this variable D? Minus 10 plus 2 plus minus 2 plus minus 4 plus 4 upon 5. There are 5 observations. Summation di by n. So this will cancel out. So minus 10 by 2. So this will be minus 10 by 5. So this will be minus 2. So we have found out that the difference that I have is now minus 2. And mu is 0. This is coming from the population, that there is no difference between the two values, between the two average IQ. Now I want to find out the variance. So in order to find the variance, I know this is a sample. So the sample variance is what? Summation xi minus x bar whole square divided by n minus 1. So I will be using the formula summation xi minus x bar whole square divided by n minus 1. This is the variance of my sample. In this case, what is the variable? ये x क्या है? X variable है difference वाला variable, the variable that I have created here. So this is what I am doing. This column represents di minus its mean whole square. So minus 10 minus 2 whole square. Then you're doing the second one, then the third one, then the fourth one, and so on. So you are going ahead and you are making the last column here. So यहाँ पे देख लेते हैं. So this is going to be minus 10 minus, और मेरा mean है minus 2 का. So this will be minus 10 plus 2. So minus 8 whole square. So 64. This is 64. This is minus 2 तो plus कर देते हैं यहाँ पे. Similarly, this is given, D is given to me as 2. So 2 minus 2 whole square. So 4 square, so 16. Then 0, then 4, then 36, and you will add all of these together. So when you will add these together, you will get the answer as 120. So you will just use the formula that summation di minus d bar whole square divided by n minus 1, n is 5, and you will get the variance of this as 30. Now you can just plug this in the formula. So your formula is d bar. In our case, d bar is minus 2. Mu is the gap between the two, which is 0 in this case. S will be, S square 30 aaya, so S will be root of 30 divided by root n. Root n will be 5. So I am using the formula of one sample t-test here because this is the same sample I'm working with. But my variable that I am using is the difference that has been created. So D is my difference variable that I'm using. That's the only difference. So this comes out to be your T calculated. From the table, your T value is this. So T calculated, it is less than the value of the T table. So T table ki value had 2.776. Calculated ka value in absolute is 1.816. So it is in the non-rejection region. So you will not be rejecting null. It means that there is no change in the marks post this training was given. The IQ level remained the same. IQ level did not change. So this is how you can go ahead and you can talk about this paired test. Paired means you are using a one-tail test, a one sample test, and paired means the variable that you are using is the D variable, where D stands for the difference. One last thing I wanted to cover for today, that is your large sample for single proportion. Beta, you can just put D there instead of mean to avoid confusion. D is the difference from the null hypothesis. This. Okay. So now I want to do large sample test for proportion also. So you remember that when I talk about proportions, the mean of the proportion was P. So if you remember, when we did your binomial and when we did Bernoulli, what did we say? We said that the mean of binomial is NP and the variance is NPQ. This is what we had written. Mean is NP and variance is NPQ. Now I am creating a variable. This variable basically represents X divided by N. So let me just show you a question first, then I will just come back to this. So just read out this question. So in a sample of 1,000 people, 540 people are rice eater. So my X variable represents this number of people who do something. जैसे यहाँ पर total 1,000 people हैं and 540 are eating rice out of it. So if I were to define proportion, अगर मुझे P को define करना है कि कितने लोग rice eat करते हैं in proportion, it will be X divided by N. Number of rice eater divided by total. So P can be defined as X divided by N. If I were to find the expected value of this P, it will be expected value of X by N. So 1 by N can come out and it will be expected value of X. Now, if my X follows a binomial distribution, then its mean can be NP. So this will come out as P. So we can say that the expected value or the mean value of this variable X is simply P. Of this variable that I have created, X by N is P. Now, similarly, if I ask you what will be the variance of this P, So you can tell me that this will be variance of x by n. When n comes out of variance, this will be 1 by n square variance of x. And if x follows a binomial distribution, its variance will be npq by n squared. So n and n will get cancelled out. So this will be pq by n. Now, what was my formula of z-test? Z-test was x bar minus mu upon sigma by root n. ये formula था x bar minus mu upon sigma by root n. Now, if I am talking about proportions, बेटा, तो ये x bar क्या हो जाएगा? ये हो जाएगा mean of the proportions. तो ये हो जाएगा p from sample. क्योंकि ये mean of sample है ना. This is mean of population. So ये हो जाएगा p from population. या ये हो गया मेरा null hypothesis p. And then in the denominator, I have to use this sigma. So sigma is the standard deviation of the population, which means that I already know how to calculate the variance. Variance is p cubed into n. So my standard deviation can also be calculated. So in this case, this entire standard error, I can go ahead and this can be written as pq by n under root. This can be written as this. I have already calculated the variance of this. So in order to find this standard error, we just use the formula pq by n under root. So when we are doing proportions, the z value that we have in this case, it is p value of the sample minus p value of the population divided by standard error of p, which is nothing but pq by n under root. Right? And here you have to make sure that you understand that p and q are taken at population value. So you're going to take these p's and q's at the population value. P is the proportion, beta. So we are not taking n. So there are two ways to understand it. If you want to take n, that's fine. So just try to think about it. Can you tell me what is the variance of anything which follows a binomial distribution? The variance of anything that follows a binomial distribution is npq. This is the variance. So if I were to go ahead and I were to find the standard deviation of binomial distribution, it would have been npq under root. ये हो जाता. So tell me something. When I use z formula is x bar minus mu upon standard deviation by root n. ये वाला formula हम use करते थे. We were using this formula when we were going ahead and normalizing sigma later on. I was going ahead and dividing it by root n to normalize this sigma. Here, I am not first finding out this sigma and then normalizing it. I have already normalized it. मैंने already हर x को ही n से divide कर दिया है. I've already divided each x by. So what has happened is that this variance that I have found out is already normalized because it has taken into consideration the proportion. I have already done this as x by n. So therefore, the only thing that I have to do to find the standard error in this case is to do p into q by n under root. I don't have to now divide it by root n. Why? Because I have already normalized it here itself. I've already written it as x by n. I am not going ahead and I am not doing NPQ under root divided by root n. No, I am not finding the normalization later. In case of proportions, we will first use the variable x by n itself, and then I will go ahead and find its variant, and then later on I will find the standard error by dividing it. So the normalization takes place earlier and then it is plugged into the formula. That is why this is a bit different. Usually, when we have the usual z distribution, what we will do is we will do x bar minus mu upon sigma by root n, and we will use sigma as summation xi minus x bar whole square by n. ये sigma का formula होता है. इसको sigma ने under root. ये sigma का formula होता है. We plug that here and then we divide it by root n. In case of proportions, the way that this variable x is defined, it already takes into consideration the proportions. So we are already saying that the p that I am generating, it is x divided by n. I have already normalized this variable in terms of proportion. So if I were to find the variance of this, the variance of p will simply be variance of x by n. So 1 by n square comes out. This is variance of x. And I am assuming x itself is binomial. So this becomes npq by n square. So this becomes pq by n. So therefore, because I've already normalized it here, I don't have to do that later. So I am simply going to say that my standard error will be under root of pq by n. It will simply be this. Remember, this is actually standard error. ये standard deviation नहीं है. अगर x binomial distribution follow करता है, तो उसका variance npq होता है, और उसका standard deviation under root of npq होता है. यहाँ पे ये नहीं आ रहा है, यहाँ पे pq by n under root आ रहा है. So this is already considering that this is your standard error. It has already normalized that variable for standard error. Yes, p is the proportion. Let me show you an example, then you will understand it. Let me take the first question. In a sample of 1,000 people, 540 are rice eaters and rest are wheat eaters. So you are given that 540 are rice eater. N दिया हुआ है आपको 1000. 540 are rice eaters. So x is given to you as 540. So this is a sample. तो sample का p क्या हो जाएगा? I will represent it by small p. So sample का p क्या हो जाएगा? X by n. So it will be 540 divided by 1000. So it will be 0.54. Can we assume both are equally popular? That means equally popular matlab ki it wants to assume its null is that the population has 50-50%. 50% rice eaters and 50% wheat eaters. Sample बोल रहा है कि 54% people eat rice, but it is saying can we assume that they are equally popular? So population बोल रहा है that they are 50-50. So what you can do is you can represent population by capital P. A lot of books to avoid this confusion, they will write sample with p hat and population with p, so that confusion is removed. Now your z variable, this is created as sample minus population upon population ka p into q by n under root. So your p hat is 0.54 minus 0.50. P का value है 0.50. So q is what beta? 1 minus p. This will also be 0.50. Upon sample size is what? Sample size is 1000 under root. So just plug in these values, and when you will plug in this, you will get the answer as 2.532. So this is your z calculated. Z from the table is 2.58. So Z from table is greater than Z from calculated, na? सो टेबल का वैल्यू ये रहा 2.58 एंड आपका कैलकुलेटेड हैज कम डाउन एज 2.532. So it is in the non-rejection region. Yes, it will always be binomial. Yes, X is the number of people who eat rice. Correct. Always be binomial और कुछ नहीं होगा इसमें. Let's read another question. 20 people are attacked by disease and only 18 people survive. 20 are attacked and 18 survive. Sample है. So sample में N20 है. Number of people who survive 18 है. तो proportion 18 by 20, that means 0.90 हो जाएगा. Sample. Will you reject that survival rate if attacked by disease is 85%? तो ये हो गया population. General statement है that the rate is 85%. So ये हो गया हमारा population 0.85. Now you will use the Z formula. So it will be P hat minus population upon population PQ by N under root. So now just plug in these values. So P hat is 0.90. P population ka is 0.85 divided by P is given as 0.85, Q is given as 0.15, N is given to you as 20 under root. So you will find this value and get this as 0.633. So Z, this is your Z from calculation. From table it is this. So calculated is less than tabular. So you will not reject your null. Let's take one last question for the day. A random sample of 400% from large population, 120 are female. But a sample, मतलब ये n दिया हुआ है 400. 120 are female, तो x दिया हुआ है 120. तो p hat sample का हो जाएगा 120 divided by 400, so 0.30. Can it be said that male and female are in the ratio 5:3 in the population? तो मेल एंड फीमेल, तो फीमेल कितनी है 3, मेल कितने हैं 5, तो फीमेल का प्रोपोर्शन पॉपुलेशन में कितना 3 फीमेल, 5 आर मेन एंड 3 आर women. So 3 out of 8 are women. 3 by 8. This is in the population. So you have to do Z test. So Z will be what? P hat minus P upon PQ by N under root. So P hat is 0.30 minus 3 by 8. PQ is 3 by 8 into 5 by 8. N sample size is 400 under root. So when you will solve this, ये 3 by 8 का value है, हाँ, 0.375. So when you will solve this, you will get the answer as minus 3.125. Again, this is your Z from the calculation. From table, Z का value 2.58 होता है. So absolute value में this is 2.58. This is my rejection region. And the value I have got is 3.125. So it is lying in the rejection region. So you will reject it. So you will say no, they are not equal proportion. ऐसा नहीं है कि male और female equal proportion में है. You will reject null in favor of alternative. हाँ, so beta, usually it will be given to you that you have to use 1% or which percent level. Okay, that will be given to you. Okay, so we will go ahead and end this session for today. Now in the next class, I just have this small thing left. We will do this differences and then I will do the last 2 tests for you. One is going to be a chi-square test and one is going to be an F test. We will do those. But a confidence interval का meaning ये होता है, it tells you that एक particular variable किस interval में lie कर रहा है और उसमें कितना confidence है वो depend करेगा on the value of your Z. So if I am telling you that I have 95% confidence interval and I create this value of mu, कि mu is between -3 to 4. It means that अगर मैं 100 samples create करूं, तो उसमें से 95 samples ऐसे निकलेंगे जिसमें मेरी जो उनकी मीन की वैल्यू है वो -3 से 4 के बीच में होगी. So I am creating an interval and I am saying that, you know what, if I keep repeating the process, if I keep finding out sample after sample after sample, then out of 100 samples or out of 1000 samples, 950 samples, 95% of the samples will definitely have their average value lying in this interval that I have created.